testing，係，hello，早晨各位 ，hello，歡迎嚟到 PyCon 香港2022。So welcome everyone to the PyCon Hong Kong 2022. My name is Scotty, so I'm one of the hosts today. On behalf of the organizing committee, I'd like to welcome all of you, like both the new friends and the old friends, to this PyCon today. 我叫做 Scotty 啦，咁我其中一個今日嘅 MC，咁好歡迎大家嚟到今年嘅實體嘅 PyCon 2022。咁上一次嘅實體 PyCon 已經係4年前啦，咁2018年，咁2019年嘅時候因為有啲事件啦，我哋冇做到 PyCon 啦，跟住去到2020、2021，我哋都係 online 嘅 PyCon 嘅。咁今年終於嚟到一個 physical 嘅 PyCon 啦。咁it has been 4 years since we our last physical PyCon Hong Kong. It was in like 2018. So a lot has been changed over these 4 years. Like the world has changed, Hong Kong has changed. But something doesn't change is that like the PyCon spirit. So PyCon spirit is to spread knowledge, to learn from each other, and to build lasting connections. 分享個簡單故仔啊！喺我哋邀請 speaker 嘅時候我今年係負責做 program committee 啦，去負責邀請 speaker。諗緊乜嘢嘅 message 最能夠令到大家共鳴上嚟肯上嚟講下嘢咧？我諗到嘅閃過嘅念頭就係有咩留翻 PyCon 先講。俗語有句話 ，OK 有咩留翻拜山先講。其實 PyCon 同拜山都係1年1次大家可以嚟可以唔嚟但係有心思思想嚟到有心思思想講下嘢所以我覺得與其話有咩留翻拜山先講唔使嘅，可以留翻 PyCon 講嘅。So this year our theme is Delight Yourself in Python, and our conference chair Sammy will explain to you what is meant by Delight Yourself in Python. So I would like to introduce Sammy Fung to give an opening speech. Sammy is the conference chair and founder of PyCon Hong Kong. He is the fellow member of Python Software Foundation, and he is also the president and founder of the Open Source Hong Kong. So let's put our hands together to welcome Sammy.
Okay. Good morning. Thank you for to join the PyCon Hong Kong 2022. And you can meet with our speakers, sponsor volunteers, as well as other participants as well. So you can make friends here in PyCon. Many of us miss the physical learning experience after 3 years of work to broaden your professional network, an event where you can be inspired, enlightened, fulfilled, and delighted to focus on Python topics that interest you. Delight yourself in Python is the slogan of conference this year, suggested by Ms. Carol Wong, one of our volunteers. It's a generic message for all the Python lovers who has passions in Python and PyCon, and it also means enjoy. For example, audience, speakers, and people who love Python. She also highlights to us that the slogan has at least 2 parts. The first part is enjoyable, fun, great pleasures, and beautiful to yourself and others. And the second part is enlightening, inspiring, and something new and surprising to yourself and others. With support from some companies to help us to make this conference happen again, thanks for our co-sponsors, AWS, and also gold sponsor Microsoft. We have received numerous proposals from speakers all over the world. We have 13 sessions today, including a keynote and also 2 tracks of breakout sessions. We also have an online track with 4 international speakers next Saturday, piloting with ConsCom, which we will tell you more about in the closing sessions. Our topics including a wide variety of interests, ranging from the purely technical to the more practically applicable. Some example of these topics, including 3D visualization with spatial data for 5G planning, taking machine learning models to production using Python and fast API, how to investigate the MySQL operator for Kubernetes using Python, as well as other how Python is being applied in architecture, engineering, construction, and even in healthcare industry. PyCon Hong Kong is co-organized by Hong Kong Coder, Open Source Hong Kong, and Hong Kong Python User Group, HKPUG. HKPUG is the key meeting group for local Python community in last 15 years. If you would like to be a speaker to share a Python project or skill, PUG can help you to call for meetings on Facebook and Meetup platform. And PUG invite OSHK and HK Coder to start PyCon Hong Kong in 2015, is 7 years ago. Thanks for our over 20 volunteers this year. So this is only part of the volunteer list. When you arrive our level area at 8:04 this morning, and also you can see on the stage in each room, you can find the promotion stand which are designed by our volunteer who studied in our school, received an outstanding award at her graduate. Our volunteer also designed this T-shirt with his initiation skills. We also have a volunteer team for AV, so you can see the cameraman and also our volunteer who control the panel with their own expertise in AV. For pre-conference, we also got a program team to call for proposals, selecting papers, and communicate with our speaker. Volunteer contact with different venues and also handle communication with the venues. We can see how they delight themselves in Python to contribute in PyCon Hong Kong as a volunteer. And I would like to give a special thanks to Dr. Hagen Schultz and Mr. Wan Won. Three of us formed the Hong Kong Creative Open Technology Association, HK Coder, in 2014, a non-profit tax exemptions organization in Hong Kong. It is also an umbrella to handle the financial process and paperwork for the local open source community events like PyCon Hong Kong. Nowadays, our next generations of director boards start to volunteering at Hong Kong Coder. Please give them support to make their contributions in Hong Kong. I will also thank the executive committee members of Open Source Hong Kong. They always become key members of PyCon volunteer teams to help with their work expertise in digital marketing, to plan and execute the marketing strategy. And they always organize meetings and conference and involved in the conference operations as well. The Python Software Foundation, PSF, grant us to use the branding of PyCon to organize PyCon in Hong Kong. PSF is a non-profit organization in US that hosts the IP right and licensing of Python programming language. PSF also runs the PyCon US. I hope you can consider to applying the voting membership, including supporting members and contributing members. It can help us to continue the development of the Python community. If you are voting members or applying to voting members today, you can find me at the Python community booth outside this hall to get a gift. First come, first serve, and until stock lasts. To sustain the local Python user group and tech community, we are looking for more volunteers to help PUG organize Python meetups and events. If you are interested to speak at a meetup or organize a meetup or providing a free meeting room for us, please feel free to reach me or contact our admins in Facebook and also Meetup platform as well. Last but not least, please visit the Python community booth at the networking area and grab the small signage for selfies to take some photos and share to your social network about your PyCon and Python experience with hashtag PyConHK. I hope you can enjoy the conference today, and I will give one up at the closing sessions again. Thank you.
Okay, thank you, Sammy. Before I introduce the very first talk, just small tips. So today we split into two tracks, track 1 and track 2. So track 1 is in here in this auditorium. Track 2 is like over there in room 801. So like if you're interested on the like track 2, later on you can move to the other room. Without further ado, let's introduce our very first talk. So in this talk, we have 2 parts and 3 speakers. So the first speaker is Dr. Zhong. So Dr. Zhong is a SVP at the Group CTO office of the HKT PCCW Group, where he's responsible for leading the group's product and technology roadmap and strategic development. He also represents the group as board member of Links Analytics and Bino Labs. So in the first part of this talk, Dr. Zhong will talk about 3D visualization with spatial data for 5G planning. And then the second part of this talk, we'll have another 2 speakers, Mr. Alex Zheng and Mr. Chris Chen. So Chris is the data scientist in HKT, and Alex is the head of data science in HKT. He's responsible for developing new analytic products and platforms for support the club's business partners. So in this second part of the talk, they will talk about website auto-tagging algorithm. So let's give a warm welcome to our speakers. Thank you.
Hi, good morning, everyone. Hi. Thanks, Scotty and Sammy, for accepting our proposal. I'm very glad to be here and see all of you here. I guess a lot of you are Python developers. I actually joined the PyCon 2018. I think that was in Cyberport. That was a really good one, and I hope you have a very good day today as well. But that has been quite challenging in the last few years for everyone. Good to see you guys. So I'm actually from the Group Technology Office, and Alex and Chris from the Big Data team. But to start with, I just have one slide to introduce us. A lot of fans here, they know Navigator for broadband, CSL for mobile, Now TV, maybe for World Cup. But then we actually have lots of digital business. Just like FinTech, we have Tap and Go, Faxi, Mox Bank. And MedTech, we have DrGo, and loyalty e-commerce, we have Cup Shopping and the Cup loyalty program, as well as we have the content, the media, Move, Blue Whale and Yellow Whale, the video streaming. The Yellow Whale is actually the largest streaming service in Southeast Asia, even bigger than Netflix. So we started the digital ecosystem journey quite a few years ago. Maybe some of you, don't really know, they are actually under PCW or HKT, but I want to tell you that there are lots of activities, development, data analytics within the company to support all this digital transformation and offering. So I'm very excited to share with you all on two topics today, one by me, more on 3D visualization for spatial data for 5G planning, and then my colleagues will share the other one. Okay, so quick, I probably keep myself 10, 12 minutes. What is the 5G wave and how we did a project for wave rollout in next few years, and also the outcome for the analytics from Python, as well as working together with the government spatial data, and the end, hopefully give you some inspiration for new application for smart city. Okay, so this chart is is about 5G, 5G coverage. So we start 5G 2 years ago, and many of you may have changed from 4G to 5G, and the coverage in Hong Kong for 5G is probably top in the world, 99% for the whole Hong Kong, 99.9 for the urban area. But 5G doesn't stop here. 5G actually evolving. There are different releases coming up. Say, for example, release 17, release 18. Just give you an example. In the future for 5G, there will be dense cell or ultra dense cell, so they are very small, that can serve even higher capacity. So if you have some super high 4K video or even 8K video, that can support that, or super low latency for your video game playing or multiplayer gaming. That's possible with the next generation of 5G. Also, an example is beamforming technology, MIMO, that kind of thing. So that can improve the capacity, for your mobile phone with the base station. But then my point to highlight here is there's something called 5G Advanced. Maybe you will see that in a few years. There are lots of things called, private network, network slicing, or wave, which I think we haven't unlocked the full potential of 5G. A lot of you guys may have 5G now, but still using YouTube, WhatsApp, that kind of things, right? But there are actually more application or enterprise services can be supported by 5G and next generation 5G. So some people talk about 6G right now. I think that's a bit longer, probably in 10 years. So to start with, what's wave? Wave basically millimeter wave, and it's high frequency 5G. So the official definition is 30 gigahertz to 300 gigahertz. But in Hong Kong, the OFCA, the Hong Kong government licensed the wave at the frequency of 26 gigahertz to 28 gigahertz, and which we got that. What you are using now for 5G is around 2 to 4 gigahertz only. So if you think about higher frequency, basically mean higher data rate. That transform more information to your mobile phone. Okay? But there's a limitation for wave, which requires the line of sight. I think most of you study physics. The wave can, diffraction, refraction, that kind of things, right? But for wave, you need the line of sight. So you have to get your mobile phone, with a straight line to the base station, then you can get that wave. Otherwise, you can't. And it can easily absorbed by moisture or blocked by trees, whatever. So if you think about deploying wave in the city, it will be very expensive because they are very small cell, and you need many of them, in the city. So so my will is we won't get wave for the whole city, but that we will have some special area with wave. So I'll give you some example of base station. Typical base station is up the building. You see my colleagues looking at them. Well, we're actually flying drones to help the maintenance, and that's supported by the 5G video streaming and low latency, so they don't need to come up the building and look at the base station. But that's another story. So usually those base stations is facing down to the street, and they have certain angle to cover, the area around that. However, you can't put your base station everywhere because there are some regulation or there are some property management issues that you have to take care. So in our exercise, we pick 50 4G cell sites and see if they worth the money to upgrade to wave for 5G. Okay, very luckily that Hong Kong government actually released a very new set of data called Dual Data Store. You can get it from the government website. And because of that, we have the 3D model of the Hong Kong. And that's why we can calculate in an outdoor environment if there's an out of sight, is there a light of sight that we can support the user. Okay, so you can see the first step is basically get the data from the government, and then we convert that into PLY format. It's a bit trouble to convert that, but there's some process you can handle that. But from there, we try to make from the base station the cones, which representing the 5G signal, and see how wide they can cover. Okay, so there are a few libraries we use in the project: NumPy, Math for carrying the volume, Open3D for the visualization, of course, pandas. I won't go through the details, but the key concept is, after creating all the cones and calculate the volume, we have to measure if those volume actually overlap with the building nearby. So if those buildings, being overlapped, we have to cut that part, of the cone. Okay, but then that's quite trouble. So, by calculating the 3D things, with all those. So that's why we turn that into dots. So we downsample that, and we turn it into, the point cloud, just like right-hand side down there. And then we count the dots, see how much coverage, that bin going that direction, can still offer to the user without being blocked by any buildings or obstacle. Okay, from my view, this is one of the examples down there. From my view, it's kind of a proxy or approximation in the real world, because if some of you study information or electrical engineering, wavelength is very hard to model. A lot of people attempt to model the wavelength, the wireless model, but never get very accurate because they're so different parameters affecting the actual reception. So we can only take this as a proxy, say as a scorecard to estimate where we should upgrade the 5G. Okay, I can't play this video, it never worked, but you can get a sense that after you have done all the things, you can have the 3D model, and you can turn it around, up and down, vertical, and see whether this is right or not, or that area being blocked by many buildings. Show you another picture here. This is more Happy Valley on the right-hand side with better coverage. So you can visualize the difference. I think this is quite helpful for engineering colleagues or even business colleagues to make the decision. And this is a business outcome. I hide the site code on the left-hand side, but then it can turn into a scorecard, say, okay, how much traffic, how much handover or user in that area in average, plus then what is the coverage of the cones, the volume, then we can score them together for ranking for a future upgrade. Okay, so but having said that, the first part for Wave upgrade in 5G is still mainly indoor. I think the next stage is going to be outdoor, but that may maybe 2 or 3 years later. Okay, so I really want to say that database is amazing. They solve a lot of works a company has to do, and actually it's free. And so I think that can help to push the imagination of smart city application as well. Some items are listed below. For example, urban planning, business location or retail store, if people walking around that street more, and transport planning, modeling, exchange, as well as I think the final one is quite interesting. If you have the 3D model, you can actually think about if I can plan my drone flying track, or if I have a property, or I'm interested in a property, whether that property has a good vision of sunlight or that kind of vision, that can be done through the 3D model. You can use Google Map now, but I don't think Google Map opened it for you to do all this mathematics and Python coding. Okay, so take a look at this website, Geodata Store, and they match with all this education, environment, technology, transport, open data by the government. Okay, before I pass my time to Alex and Chris, I want to say, we have lots of digital offering across the company. So if anyone of you interested, or you're a student or final year student, feel free to talk to us. We are just outside in the booth. We hire internship, summer, winter internship as well, and keep that email. That's a fast track application. If you are interested, just send your CV there, and we will find a good colleague to let you know if we have some interesting posts. If you are not interested in that, we still have the Move music coupon discount. I found it was especially special for this PyCon conference. So feel free to grab the leaflet outside. So thank you, and pass the time to Alex and Chris.
Good morning. Chris, come on board. Thank you, Tron. So after Tron shared with us all the interesting information about the 3D virtual data building, we actually want to talk about consumers, everybody in the audience, you and me. We actually, we are part of the data science team in HKT, so we analyze customer data, and then we try to provide better services to our customers. One of the business that Chong showed us earlier, we have a business we call HKT Club, which is the loyalty program. So anyone is a part of the HKT services, you can join automatically you're part of the club member. Or you can join club even if you don't have any business or services with HKT. So the benefit of the club, you get points when you spend, you buy from what we call club shopping, travel, or insurance. Okay. So our shopping site, we have it's actually traditional classic problem we're trying to solve. We know our customer shopping behavior on the site, okay? But we want to provide better services. A lot of time that customer coming to the site, they browse, a couple of items, then they leave, or they put on a shopping cart, or they forgot about their shopping cart, okay? So limited information we actually gather from the behavior on our shopping site, okay? So what we really want to know is, thank you, you're so kind, okay? So in addition to the behaviors on the shopping, our shopping site, we also like to have a broader understanding in terms of sites they're browsing. So we have a better interest understanding of our customers, and the objective is to provide better services. So the old approach is when we classify a website, mostly it's just by keywords. And then nowadays, a lot of keywords are really identical, so we can't really differentiate website about exactly the contents and also the interest of our customers. So Chris will share with us today a different approach that we tried and some of the initial results that we can share with you. Okay, Chris, thank you.
Thank you, Alex. So for this, so our goal is to identify the website in the internet to see what those websites is about. Maybe you are running an e-commerce, like some beauty products you are selling, and if you want to know, like recently there are some websites that is related to beauty, and they are also selling similar products, and they are getting attractive and more popular in different forums or stuff, then you will probably want to know that website exists, and and then you can analyze your competitor. So to doing the automation, like because the internet is so large, there are so many websites, and people are using different words to classify those, to label their data or describe their products. So we want some intelligent stuff to help us to automatically annotate the website. So basically, we try a few approach. The first one is we try to do it like ask the model to look at the websites unsupervised through some topic modeling to see what those website is about. Like we give it all a lot of websites, and he help us to group the websites itself. Like you will say maybe some websites is about the beauty, some it will talk about skincare, you will talk about protein, but we don't know what those websites is really about. But it already help us to like grouping some of the websites. But using this approach, it's hard to say If I want to know all the websites about beauty, and how can we know when the model tell us there are 10 websites, how accurate it is? Or maybe the model is like 60% accurate, how can we improve it? So we abandoned the unsupervised approach. We turn to some supervised approach, like test classification. But when we are talking about classifying through in the website, there are lots of different business use case. Like this time I want to know beauty, next time I want to know why, and next time maybe golf or other sports. There are lots of different topics we want to know. So if we are doing some test classification, we don't want to do a lot of labeling of different websites. So in this case, we want to have some using some pre-trained model that maybe encode some language stuff in the model, like the fast test one. You try to ask the model to go through all the test documents that are available and learn the test within those documents. Like you will learn maybe say you have some sports website and you will be linked to certain keywords like sports shoes or other like badminton or those keywords. They will all link to the same, they will be encoded to similar meanings. But so use this fast test library, we achieve maybe the accuracy 76%, but that's not enough for us because we want to, like the internet is so large, we want to filter the websites as accurate as possible. So we further go further, we use some pre-trained transformer model. What's the difference between it and the previous fast test? The previous fast test tried to encode the meaning of a single word. And the transformer model tried to encode the meaning of the whole document. And with this model, we are able to achieve a better accuracy. Like I will use around, we will improve it from 76% to 90 something. And if you imagine it's like we filter, say, from tons, millions of websites and we reduce the wrong websites by 20%, then you don't have to look at those wrong websites again and again. So this is some background of the model, but if you go to the internet and search transformer, then you will get a lot of this information, so I will skip it. But so let's go to how we implement it. Talking about that, those states of art or model, maybe you maybe have some knowledge about some deep learning stuff, and maybe you will imagine that deep learning stuff is complicated. You will use a lot of time to do the training, but actually there is a very good Python library called Hugging Face. And with this library, they provide the API for you to implement different states of our model, like with few lines of code. Like I will show you how easy it is. In our case, for the training of the model, you just like 26 lines of code, and for prediction of this model, you only need 20 lines of code. It's really easy, and it's not just about the classification. It's also about maybe you want to build a chatbot. If you want to do some summarization, you want to do some image generation, all this you can do with few lines of code in Python and with the library. So yeah, we finally achieve a good accuracy, and we can classify the websites in a very good. Like we know some colorpop.com is about beauty and fashion, and because we also have how popular each website is, then maybe if you have a e-commerce like selling beauty product, you will know, yeah, recently there is another website about beauty and it's rising its popularity, and maybe you want to have a look on it. Okay, so, but that's not the end of the story. When we get the model, we have the result, but it's also about building the whole systems for our business user to use it. So to implement it, in addition to Hugging Face, we actually have a lot of stuff. Like we use the Scrappy to get the new websites, content of the new websites. We have, say, for just like I've mentioned for e-commerce, sometimes you care about the golf, sometimes like recently you care about the phones. Maybe next time you want to know more about the some camera stuff, so you have to keep calling the internet. We are using Scrappy to do it. And then after you get all those websites, you want to do some analytics, we use PySpark to do the analytics. And using Google Cloud, it helps us to make all the implementation easier, and we can have a better control of our resources. So this is a detailed implementation. Imagine from the first part, the business may have a server website that is related to the things that they care about. Then they just have to call the cloud, subscribe through maybe a API, and then they can get those links to us, and then we help them to scrap the result. And then we will do the model training on schedule model training tasks, and then do the ML ops with Vertex AI. And finally, with the final result, we also do the analytics in Spark and using it to provide some insights to our business user. Yeah, so this is the key takeaway from my part is we build an automated website classification for competitor alert. And we also use the pre-trained language model to get a very good classification result. And even with small data set for small, it's dozens of websites or hundreds of websites, and then it will help you to identify all the results, maybe for millions of websites. And the final one, Hugging Face provides you a good API that you can implement some good models with maybe 20 lines of code. Yeah. So finally, the most important message. Yeah.
Feel free to talk to us technically, whatever in our booth out there. We're at the very back or at the corner, so yeah, don't hesitate to talk to us. And
we don't have any gifts, but we are the gifts.
Yes, we are the gift.
Come to see us.
Yeah, and some stickers finally. So is that Q&A time?
Actually, yeah, feel free to ask questions. Yeah, please to the speakers. Yeah. Testing.
Hi. Could you turn back to the? I'm more interested in the first part of the presentation on the mapping bit. Could you explain briefly why you are on a distribution, on the wave distribution thing? Why are you calculating the cone volume rather than the area of coverage?
That's very interesting. Well, I think you can do that way. If you think about, not doing the cone, the volume, but just on the surface area, that's possible. I think that's a very interesting idea as well. But then we have to calculate. It may be a projection from the cone, but we have to find those dots really, on the surface. And I think that's a very good suggestion for the next enhancement. And that in the real life, it could be more sophisticated than that. We believe it's line of sight, but sometimes people actually try it. It can defect a little bit, and then that will change the model as well. So I think wireless modeling, especially for wave, is still a quite big, interesting research area. Yeah, even in academia.
And you are happy with the result you get from calculating?
Well, at the end, I think we try not to rely on just the volume or the dot points, but mix with other network data. For example, how many users actually stay there or use data there. If they pass by there, hand over, doesn't mean they use data. Then there's no point to upgrade that cell site. But if they are like outside the SOGO, they really stand there and then use a lot of consumption waiting for friends. I think that worth. But then you also ask the question if SOGO is quite straightforward. I can think about that SOGO. But maybe there's some other places in Hong Kong that we didn't know. so we can take out from the data. Yeah, thank you.
Hello, I would like to ask for the second part because I'm quite curious to know how do you determine the popularity of the websites that you are going to look through? Because you said how do you put in a label for each website, but how do you determine the popularity of the website that you need to go through? Because you said you want to look at the competitors.
Yeah.
How do you know that who's your greatest competitors in this case?
Okay. It's actually, well, if you look at like popularities, we can look at like a number of visits and the duration of visits, so that easily we can identify that. We're not looking at like a specific competitors, because as in we're running a actually e-commerce and loyalty website. So we have, roughly speaking, in terms of our market share, we're like a number 4, number 5 comparing to like the bigger ones. So for us, it's more about instead of like going directly to so-called competitors, we're more focused on have a better understanding of our customers. We provide them with a better experience when they're on our shopping site, give a better like a recommendations. So that's our sole objective. Thank you. I spent a whole night last night practicing my Cantonese. I'm surprised that actually we all speak English here.
You can give it a try. You can give it a try here. So any other question, guys? Go.
Is that in Cantonese?
Really Cantonese?
Of course, please, yes.
No, I think I stick to English is better. So I would like to know more about the implementation detail of the Scrappy and also like the training stuff, because like I have done NLP before, and I know that like using NLP and also the Hugging Face model can, like, if I train with a very long approach and I have a very long corpus, and it will easily get overfit. So I would like to know like how many approach you have trained for the data, and I know that like for each corpus, the longest length is like 500 something. So like what information in particular for each website you have scrapped in Scrappy so that you can determine the text label for the website?
Yeah, interesting. Yeah, that goes to a very technical detail part. So yeah, for the Scrappy part, actually what we get is the content of that website. When we get the domain of the website, then we go to that website to get the content, and we will store the whole page, and then we will do some data cleansing stuff. And for the training part, it's about how to evaluate the model accuracy and also doing some regularization. Yeah, so the part that you are aware of is doing the, like how to monitor the overfitting. Is all about the ML ops that I'm talking about. You will monitor the feature importance, monitor the performance of the model on some evaluation set. Like what I've mentioned at the very beginning, we will receive, say, maybe some websites that that is cared about. Then we will use that website. That website will relate to particular content. Then we will also have another group of websites that is unrelated, and use it as an evaluation set to see our model performance. And we will keep track of it with the ML ops provided by Vertex AI. Yep. Thank you.
So any more questions? I think we still have time for one more question. So if no, actually, I have a question for Dr. Zhong. So just a stupid question, sorry. So the MM waves, you show the wave length is quite close to the microwave, right? Yeah. So will it like heat up my body when I use 5G?
Wow, that's very challenging question. As a mobile operator, the answer is no. Yeah. Well, I got this question. I study wireless since 20 years ago. So I think the official answer is there has been quite a lot of attempts to study whether there would be physical, impact on human body. The answer is yes or no, or there's no answer. But recently, people ask, if that should be changed, or there are people talking about, this wave, they usually is transformed in very low power. There are restrictions, so they can't do that. But then, there are still people talking about, if you want to see the impact of human body, it may take 20, 30, or 40 years to see whether it's true or not. But then even if you have those data, the answer is still statistically not really significant. So I would say unknown, but then official no.
Thank you, thank you. Thank you.
Actually, I think the best way to protect yourself is to leave your mobile phone at home. Just don't carry it with you.
My personal advice, when you sleep, don't put it next to your head. That's it. That's good enough. Yeah. If you have kids or babies, just don't put those wireless router or mobile phone next to them. Yeah.
Thank you. Thank you. So thank you for the speaker. Let's give a round of applause. Thank you.
Thank you.
Thank you, everyone.
Thank you.
Thank you.
So up next, we have Calvin to introduce our next talk.
Thank you. I'm not the speaker, sorry. I'm Calvin from Open Source Hong Kong. Before I introduce the upcoming session, I would like to check, did anyone watch the Marvel series about the what if? Yeah, because the topic is called what if Python plus Azure. So this Python, for this topic, Python Azure innovation is more than a linear path. It's a prime of endless possibility where single choice can branch out to the limitation innovation with the Python. In this session, Ethan will be mastermind to showcase different use case scenario of implementing Python in various industry and domains. Join him to discuss the new possibility with the Azure and Python. So let's powder the question of the what if together. So Ethan is a seasoned principal digital solution architect with over 20 years of experience in application development, cloud technology, digital solution, big data solution, data analytics and science. So So as a technical evangelist and strategist, he is very active on the public speaking, webinar, and contribution of technical article and open source code repository, whose topics include AI, machine learning, data analytics, and solution design and best practice with Microsoft Azure, Azure Cognitive Science Service, Azure Machine Learning, and Azure Databricks. So let's your turn.
Thank you.
Yeah.
Thank you, Kevin. Yeah. Okay, perfect. Just make sure. Oh, okay. Seems the screen resolution is not too very high. Wait a second. Wait a second for me. Let's try to change the higher resolutions. Is it possible? Just try one more time. Okay. Don't touch it, okay. Just leave it work, right? Don't touch it, okay, no problem. Okay. Okay. Let's kick started. Let's kickstart the journey, right? So, good morning, everyone, okay? And welcome to the PyCon today, okay? On behalf of Microsoft, I've tried to share with you the what if, okay, about the Python plus Azure, right? Let's ponder the question together, right?
Let me quickly introduce myself as well. I'm Ethan, a global technology strategist at Microsoft, technical fellow in Microsoft, to helping our strategic customers to drive the digitalization, technologies, definitely any problem related to the coding, programming is also related to me. So I'm an active contributor in the open source communities. This is my GitHub and my public Medium article, always talking about the Python, Go for language as well. Feel free to check it out anytime. So I have 30 minutes for today's sessions. Let's talk about the agenda. So agenda of today's, I try to handpick 3 main topics today to you here, right? About the serverless, about the data analytics, machine learning, and artificial intelligence. The first thing about the SDK, software development kit. Why I'm trying to picking these 3 main topics for the possibility we can build on Microsoft Azure. Let me try to tell you something why, okay? I don't know why the screen resolution is relatively low in here, but I'll try to use my mouth to try to speak on here, right? Let's think about the top usage of the Python, right? Let's take a look back, okay, the statistic figure of the Python. What kind of things we are building with the Python language nowadays before I'm talking about the Microsoft Cloud? The first thing, okay, like the HKT sessions, we are building the data analytics. The second thing is the web developments. The third thing we are building using Python is using the DevOps, system administration, web automation script as well. The fourth one, obviously, machine learning and artificial intelligence training as well to build the sophisticated machine learning models with the Python languages. This is not telling by me. It may be working by you as well from the statistics of the developer survey, okay, of last year, 2021, right? So Python is not just for the artificial intelligence, machine learnings, and also for the automation script, for the server website development as well, right? So that's why I'm trying to handpick this 3 topics, talk about the serverless. Definitely I need to talk about the top trend, about the machine learning data science as well. I'll also talk about the SDK, how we use the micro SDK to build the program with the cloud more effectively. Okay, let's talk about the first topic, serverless, okay? The serverless, okay, as you can see from here, right? Actually, Microsoft Azure has multiple service offering can host the Python, right? Definitely, locally, I'm using a Windows laptop nowadays, a Windows 11 in here, right? Definitely, you can use a Mac, okay? Instead of Mac, okay, how can we run the Python program and then serve for the productions, right? We understand that we can build a program from your laptop, from your Mac, but how can we serve the program, okay, for the productions? Obviously, with the cloud, okay, it's more scalable, okay, to help you to serve the application publicly, no matter it's the website or program or whatever, right? From the left to the right, I try to explain you a little bit, right? Definitely, you can create a very simple Linux virtual machine or even Windows virtual machines, okay, to host your Python program, no matter it's web or whatever, right? Nowadays, okay, you can see the statistic, the Python developer survey as well, okay? From the trend, half the people, right, try to serve the Python program using the container array. It's not just putting inside the virtual machine and serve it directly. This is another way more effectively to deliver your program, more easily to do the DevOps integration as well. Use the container array to ship your Python program out. Definitely, I'll just quote some example. As I said, you can build a website with the Python program. You can use the Flask more simply, okay? Django framework, okay? You can just import it, and then you can serve the website. Either way, you can use the virtual machine, just open the firewall port, you can release it. Use the container package as the containers, and then you can serve it more easily as well. And Microsoft Azure also has more seamless way to serve your applications in Python more effectively, like the serverless. We have the app services, we have the functions, we have the container instance, all of that without consideration about the computation power, the scaling capabilities. You can more easily to control, to focus on your Python program development. And lastly, okay, we also provide a power platform, right? Something like a low-code, no-code technologies, okay, infused inside there to help you to use the Python program to accomplish together to build the program more effectively in here. So let's talk second layers, okay, the middle layers, the database layer. We talk about we have various offerings can host your Python program to serve for the productions. No matter websites, okay, no matter lucky draw programs, okay, wherever just limit is your imaginations, you can use Python to pose in the Microsoft Azure as well. How about the database, okay? It's also able to connect the database with the Python as well. We have the SDK, obviously.
It's all supported. No matter classic way using Microsoft Azure SQL database, Progress, okay, I know MySQL, we have a section in here as well. We also have the past version of MySQL database as well. We also have some NoSQL database. All we have is the SDK to help you to connect, just import it more easily to effectively connect with the past database and then just focus on the coding. And lastly, we have the DevOps integrations. Obviously, Microsoft purchased GitHub a few years back, right? The DevOps integration is fully integrated. So from this portfolio, you can see Microsoft seems like a house, okay, to serve as a home for the Python programming hosting as well. If you think about the hosting, serving your Python applications from the server perspective, web serving perspective, right? You can very easily to leverage Microsoft Azure to serve it. So we understand the portfolios. Let's talk about how we do it, okay? I just quote very simple example of how we very easily to spin out the apps, service, and containers, okay, in here. So I just would like to have a look in here. How many people familiarized with containerization here? Anyone try to package your Python program in containers, all right? Okay, I see a few people in here. It's a half already, right? Just check it out, the 2021 survey, okay, in Python developers. Half the people already using container to develop, to deliver the program already. Okay, just back to here. The app services. The app services is the platform as a service solution to help you to spin out the platform, okay, to host your Python program. Definitely, you can see the runtime version. You can select starting from 3.6 to the latest version P49. You can see that, okay. If you want to have the free trial, just type the SKU is free, okay. This is the command. This is the command. Just check it out. Maybe just Google it. You can just AC is a command very easily and effectively to create a instant to serve your website. And then you can deploy your application, Python application, like Flask website or Django website, okay, wherever it's an API, not just website, right? You can just serve it in there with the app services without any doubt or consideration about the infrastructure areas. Definitely, I also respect the classic way you can use a virtual machine to host it, but consequently, you need to manage the entire environment, patch the environments, to create a virtual machine, install the dependency, but with the app services, all in here, just like other counters, just run it as it, right? So another way, okay, why I'm trying to focus on any containers guys in here as well, we have the container instance, right? Very, very easily to help you to host a containerized application in here, so, right? So this is a very simple example to how to create a container instance in here. Obviously, I just coding in the Docker Hub, the Bitime Python, the very classic containerized sample in here. Okay, you can just spin up a containerized application very easily with the 8.80 or any other port you want to define it. This is the easiest way to host a containerized Python applications. The third way, okay, you can think about using the functions, okay? This is another serverless way to host applications. I will give you some example what kind of things we can build in here, right? Also, okay, the function is out of the box support the Python as well, okay? You can just select the Python, select the version you would like to build, right? 3.9, 3.6, 3.8, whatever you want, okay? And then you can create the actual function to do the serverless stuff, like API, integrations, web, wherever you can build. That's the app service. And other things, okay, as I said, we have the local development platform to help the developer as well, right? I think more or less some of the people may be in the data science and data analytics space in here, right? We have the Power Platform. Power Platform, we have the Power BI to help you to easily to visualize the data in here, right? Okay. In Power BI, some secret tips in here. Okay. Power BI obviously is the local, you can drag and drop the data. You can visualize it very easily. But in some cases, you would like to assistant. I'm the code there, obviously. And then I would like to some assistant to get the data or visualize the data, filter the data more effectively in here, right? The Power Platform, the Power BI is also support the Python script in here. Just like if you try in your Excel, okay, nowadays it's also support the Python as well, right? Very simple to import the data, filter the data very effectively, okay? I can say hybridly to make your visualization more faster. That's the Power Platform. Yep. Actually, I have the secret tricks about the Power Apps as well. You can build your Python. Okay, just let me PM me. Okay, if you want to. That's not an official way. Just let me know if you want to achieve it. In some cases, Power Apps is a no-code development tool as well. It's also support Python. So, we talk about the serving layers.
the logic layers, for the integrations, for the surfing, API, the web, right? We should have the database, right? So as I said, we have the libraries, okay, out of the box to help you to have your Python developers to connect to the database correspondingly. We have the Cosmos database. In Cosmos database, a very quick introduction. We have few type of the Cosmos database you can choose. First one, SQL one, okay? And obviously you can use the Mongo as well. That's the same thing like you develop with the Mongo database as well. Just PIP and still as usual, PyMongo, and then you can install it and connect to the database correspondingly. For others, okay, like the Azure SQL database, like the Progress database as well, okay, like the MySQL, just simply import the connectors. You can connect to the corresponding database very effectively with your Python code as well. So that's the database. And how do we develop in here, right? How do we develop? What kind of development tools we have, okay? From the reports, okay, you can check it out reports, okay? Now, how many people using PyCharm nowadays? Any using PyCharm? Yeah, 1 people, 2 people, okay? Now I can say the Visual Studio Code is the top one, okay? The top 1 selections of the Python development. Obviously, so many people think about using the IPython in here, right? Python in here. Actually, the Visual Studio Code is also support the Jupyter Notebook nowadays. So that means you can do the statistics analysis in the Visual Studio Code, okay? Very effective. So that's why it's over Jupyter Notebook already. That's very convenient. Nowadays, I'm also using Studio Code to use for my data analytics as well. Not just IPython, we also support the visualized one, right? So with the extensions, with Python extensions, auto-complete in-tag sense, collecting, debugging, unit testing tools, all in there, you can very effectively to develop the Python code with the Visual Studio Code. Okay, just check it out. It would be help you. And definitely, Visual Studio Code has a lot of extensions to help you easily to connect with the Microsoft Azure to deploy your code in the cloud as well. Yeah, so what can we build, right? What can we build in here? Okay, so many stuff, so many information from Ethan, right? Okay, so we understand so many things. Okay, we can, on the platform stuff, we can host something, right? What kind of thing we can build? I just handpicked some of the example here, right? You can see the light in here, right? That's the functions, Azure function. Definitely, I will use the Python 3.9 something. This is a web-based retail application. Just pick up online orders from the queue and process them, result in the database, right? I just try to like to illustrate in here, just like a classic example, the message queue from the very, very front end. Okay, someone orders, okay, at the web, at the mobile, and then queue it in the service bus, okay, and then for the functions, okay, definitely you can use the Python program to develop, okay, to connect to the service bus very seamlessly. That's the queue, okay, and then process it, do whatever you want, maybe doing some basic filterings, columnize the table, and then save it, okay, in the Cosmos database, or Azure SQL database, or Progress, or MySQL, whatever you like. That's the processing, okay? You can use it in here, right? You can see, you can apply your Python program in almost everywhere, right? So another example about the mobile backend of the financial services, I'm trying to mobile banking, okay? Mobile call from the web API, okay? From the mobile front end or web front end, just imagine, all right? We can process it, okay? With the Python serverless program, okay? With Python development. We can call and process it, and then further process it and send the push notifications. That's also able to achieve by Azure functions with the Python support. Another example about the real-time processing in the healthcare, about the machine learning and AI, okay? Because the previous session talked about the AI something, definitely, okay? Python, okay, is strongest area to do the data analytics, artificial intelligence, right? So in Microsoft, we have some of the canned AI service to help you, okay, to do the computer vision more effectively. In here, okay? Just imagine you have your storage bot in here. The storage bot can be saved a lot of PDF documents. That's the images, okay? In the images, you cannot extract the information, right? You cannot do the NLP directly from the images. You need to do the computer vision, extract the text value before I am doing the advanced NLP or NLU, whatever you like, right? So in here, I also use the Azure functions. That's the serverless program. So it's like a glue, okay? Connected to the block storage, grab the PDF, and then process the PDF, okay, and then extract the information from the images. Consequently, I will get the value, okay, something like a document, 5 pages, all the texts, I can grab it, and then save it in the storage, wherever you like the NoSQL database, like the blocks, like plain tasks, whatever you save. That's using Azure Functions in here. A lot of the use cases you can build. So another example, okay, just last two examples, okay, from the IoT as well, okay. I can see previous section talk about something like IoT, right? The IoT at the back, how do we gel together, right? You can use the serverless functions, something in here, right? You can also see the Python logo in here. Just like I mentioned in the middle, to process the event from the device, okay, we have the IoT hub to help you to save the data, save the sensor signal from the device, right? And then from the Python perspective, we can easily to connect to the hub and then process the event wherever you like, right? Send the push notifications, advanced data analytics, wherever you like. Okay, that's the last example in here, right? This example about a serverless bot program, something like a chatbot, right? Chatbot nowadays, or something say it, try to rename it as an intelligent assistant, something. That's the chatbot anyway. Nowadays, starting from 2021, no one tried to build a chatbot nowadays because it's so boring, right? Now, voice bot, okay, with the voice, okay, back and forth, okay, with the voice response. You can say something, you can listen from the bot as well instead of just playing task mode, right? So with the Azure functions, okay, or using web app or container, whatever you like, you choose. I just pick Azure function more effective to build because it's completely serverless without thinking about the computation powers. You can receive the voice from the customers, okay, from your end user, okay, to listen what they say, doing the speech to text, and then extract the text value, and then we can use the NLP to map corresponding intent and then give it response to the end user. This is one of the examples you can build. That's it, okay? You can see so many imaginations, okay, using Python, okay, hybridly with the cloud resources as well. From the cloud perspective, you can more easier to make your ideas to the production mode. So let's talk about second topic, data analytics, machine learning, artificial intelligence, okay? What kind of things we can have from Microsoft as well, right? From the very low, okay, to the very top, okay, except the power infrastructure, obviously, you cannot program the CPU, the GPU with your Python program. That's the assembly, right? Obviously, you can use that. You cannot use that, right? So that's why I skip it. Okay, the second layer is the productivity service framework, okay, the data science tools, okay, or as I said before, right, some of the pre-built AI machine learning services, you can just leverage it, right, from here. So let's talk about one by one in here. Productivity service, right? We have someone saying Microsoft is not open source nowadays, maybe old days, Windows, okay? We are not open source. We are the home for the Python as well. We love Microsoft, right? We love open source in here, right? We are supporting lot of the open source framework like PyTorch, TensorFlow, Scikit-learn, obviously, and the open source framework of the model management, ONNX. That's all open source popular framework we are supported as well. We also provide some of the service to help you to develop the machine learning AI program more effectively with the scaling manners, like the machine learning virtual machines, okay? Just imagine you are newbie to open up to try to Python program to develop very sophisticated in day one, okay? You need to install so many Python library, okay? Maybe you miss it. Okay, we miss it. You need to configure it so many times, right? We may take half day to prepare a laptop to get ready to production, to start development, right? With virtual machines, okay, machine learning virtual machines, that's already all installed the package already. Oh, definitely, it's kept up to date by monthly basis. Just bring it up, and then you can start the Python development immediately without any waits, right? Definitely, we also have the friendly partner like Databricks do great in the data science, data engineering, the machine learning model as well, okay? We also have the first-party machine learning service to help you, help the data analysts, the data developers, okay, to build a machine learning model and data science program with our platform as a service. At the top, okay, you can use the familiar tools, no matter using Jupyter Notebook, Command Line, as I said, Visual Studio Code, you can also use it. That's a Streamlit integration in there. You can just seamlessly deploy your program notebook to get to the cloud. Okay. Lastly, we have the domain-specific model in different periods, just like a human, artificial intelligence. Try to simulate the human behavior in here. We can see it, we can speak, we can say it, we can listen, understand your language, do searching, do decision management as well. I'm not trying, because I only have the 30 minutes, I'm not trying to explain all the cognitive service in here, right? But it all give you an impression, okay? We have multiple dimensions of the cognitive service in here. As I said, visions, like the computer vision, as I said, grab the, just like OCR, okay? We have the form recognizer, detect the object, okay? Detect the people, detect the face as well from the vision pillar. We have the speech to text, or text to speech in the new manner, just like a normal human, right? We can help you to make the decisions. We can help you to do the web search without any further development with your own, right? That's it's much better to start from scratch. If you ask me nowadays, do I need to train my computer vision model to detect something, the object? You're not necessary to build it, okay? To check it out, my medium example, I'm trying to capture the face from the face API to try to detect the sentiments, okay? The ice breaking, because everyone is eye blinking. From the FBI analysis, if the people try to keep blinking, right? Keep blinking, that's something like the tell the lie, right? So I use the face API, okay? Try to detect the frequency of your eyes blinking, and then we can detect the people is lying or not. How do you can apply to such kind of technologies? Maybe some of the interview sessions, you can apply it. So I will skip this one. Yeah, just check it out. In the last slide, I will tell you, right? Azure Machine Learning, I would like to share something with you as well, okay? Azure Machine Learning is the space, okay, for the machine learning and data science developers, okay? As skill for all, okay? I know some of the younger generation, I see some of the younger generation in here as well. That's skill for all. If you're not studying a PhD or data science master as well, you are also welcome in here, right? Because we design a GUI in there, okay, to help you more effectively to build the data science, right? So like a automated machine learning, we can build in here very easily, or even the advanced developer, just like you guys, some of you, right? Just like me as well. You can use the program hybridly in there and support Python coding. It also support the machine learning operation as well, MLOps, to help you more easily to deliver your program to the productions. It also support the responsible ML, okay? That's automatically help you to detect the bias of your machine learning models. And lastly, the open source, okay, it's open in the inter-cooperate. It supports the Python integration and lots of service integration as well. I just would like to introduce one thing for you in here, it's a cooperative notebook, right? In your local PC, okay, or your Mac machine, okay, you cannot cooperate the development with your colleague, right? Okay, with the remark, okay, something like maybe some of the people you know, okay, using the co-authoring program, using the Excel Word program as well, you can co-author. In the Azure Machine Learning, it gives you one benefit. If you are co-authoring to something in here, no matter notebook or Python program, that's a cooperative. You can pair with your colleague to program together to develop the same program with a conflicts, obviously. Let me share about the customer story, what kind of people is using Azure Machine Learning actually. Fashionable, right? It's something like a retailer in here, in the US, in Hong Kong, right? They're using Azure Machine Learning. Definitely they love PyTorch, using the PyTorch framework to build an AI algorithm to detect the code design, and then understand the trend, okay, and then meet the fashion company as they need it, okay? They are using the Azure Machine Learning to train the model with the PyTorch frameworks, all inside the Azure Machine Learnings. So let's talk about the third example, okay? SDK, okay? So I talked too much about how do we connect with the Microsoft Azure. From this session, you understand I can use my program, okay, Python program to connect with the cloud, okay? I deploy to the cloud through the web, through the API, connect to the database as well, cloud-based scale database, right? How do we connect to there, right? We have the developer SDK in here, right? Something like the authentications, obviously, you don't want the database to be public. Some of the websites don't want to be public, some of the secrets, right? How do we connect to there, right? You can just import, okay? Import the SDK very easily, okay? To connect to various services, something like what I said, the cognitive service as I share with you guys, okay? Azure Machine Learning as well, okay? And other service, you can import the SDK and then connect to the various resources very effectively. Just back to the top one, okay? Provision and manage the Azure resources with the management libraries, right? Back to the trend, right? Just remember the trend. The first trend about the Python nowadays, what we build is the DevOps integrations, right? a lot of people try to use the Python to do because so easy to learn, okay? So many people will love it, right? You can use the Python to do the DevOps pipeline, right? But DevOps pipeline is just the stuff, right? I'm not stably trying to call the API to do the integrations, right? That's not a good idea. So that's why just pip install Azure SDK, and then you can connect to Azure Resources Panel, and then create the resources, configure the resources, scale the resources, whatever you want very effectively. That's make the DevOps integrations. So, seems like Python is love Azure, obviously. Yeah, that's the new home for Python, right? Just check it out, just scan this QR code, okay? I just grab a website. We have the official website, okay? Dedicated website. Talk about what is the imaginations from Azure, so okay, can navigate in the Python as well. Just feel free to check it out. So, you are also welcome to join our dev communities. We have booth outside there as well. You can just pick some t-shirts, stickers, whatever you want, just scan it, okay? We will frequently update the news about our developers, news, okay, event, trainings, goodies for you, okay? Just check it out, just like it, and you can get the news latestly. And lastly, thank you, just on time, okay? This is my GitHub repository, contains some of the Python program, including the data analytics, web programming, okay? You can also check in my mediums, okay? As I said, one of the example, ice ranking program is one of the article in there, just check it out. I also have the Facebook scraping program analytic as well, using the Azure Task Analytics to detect the sentiments of your Facebook posts, a new posts, right? You can also check it out in there. I also hosting a HK AI communities in here, okay? A lot of AI expert and developer in the Discord community, okay? If you, just raise your hand, like how many people are using Discord nowadays? I believe all the people, right? Discord, right? Yep, I love it so much, right? Just join the Discord community as well, just check it out. This is the AI Hong Kong communities you can join. So, thank you everyone, okay? I think now is the Q&A time, okay? Feel free to ask the questions. No stupid questions, just feel free to ask, yeah.
Hello.
Yes. Just exchange ideas. No problem. Not a question at all.
I have a question on the first part. So,
yes, sir.
Do you have any advice on orchestrating the Azure functions? Because on one slide you mentioned you use multiple Azure functions to handle web requests.
Yep.
So, may you share some thoughts on that?
Yes, that's my plan to publish article. You got my mind as well. I will use the master functions to control all the functions, something like a millions, right? That means so many millions, right? We need to have the master to control all the millions functions, right? I built a master functions, okay, to control all the slave functions, right? So maybe in the documentation from Microsoft, we call it durable functions. The concept is we have the orchestration functions to orchestrate all the millions work. Maybe some of the millions is try to grab the news from somewhere, okay, put data processing, okay, and then send it the email, whatever, right? Usually I will use the separated function to control all the million words. Or another way, you can, if you're using the data stuff, processing data, you can use the Azure Data Factories. It is out-of-box orchestrator to help you to orchestrate the functions, right? Without coding, this one, right? This Azure Data Factory without any coding, but obviously I also love coding, so that's why I'm using Azure Functions to orchestrate all the millions works. Yeah, one other advice for you, yeah.
Hello, any more questions? If no, I want to ask a question about if I want to, if I'm using the Databricks and I want to do some ML development, what tools I should study for it?
The ML ops, right? The ML ops stuff, right? What kind of tools you would like to pick, right?
Yeah, I have to study it.
Yeah. So many. Depends. Databricks, Databricks is the underlying computation layer is Spark, right? It's not native Python. It's PySpark. It's not a Python natively. Okay, you need to remember. You need to import the PySpark, okay, machine learning language, right? So you will, if you're using Databricks to build a machine learning or artificial intelligence model, you need to rely on the PySpark machine learning model. This is the first underlying baseline model. But if you're using Azure machine learning, as what I said, the PyTorch, okay, the TensorFlow is all support. It's not a constraint within the Spark. computation engine, right? Depends on your choice. If you go Databricks, right, Databricks also has the way to do the ML ops, right? Like the ML flow, okay? Out of the box already supported in the Databricks as well, okay? This is streamlessly, okay? It doesn't mean no integration with Azure Machine Learning as well, okay? You can make it integrate, but more streamless, I will encourage you to use the ML ops offerings, okay, from the out of the box from the Databricks as well. But if you are natively using PyTorch to build TensorFlow to build, okay, obviously you can build on top of the Databricks as well, but not streamless, right? So if you are building streamless, very advanced AI model within the cloud, okay, with the cloud training powers or serving powers, we will encourage you using the Azure Machine Learning. So, any others?
Any questions?
Any questions?
If no, I have a question.
Yeah.
Yes, yes,
So
sir.
I think you know really well like Azure services. So, like if I'm a Python developer, then how do you compare like Azure's offering to your competitor, like other?
Our competitors,
Yeah.
right?
What's your like strength in Azure's offering? Yeah.
I love the statements like no competition, no compare, no hurt, right? That's classic, right? No, I'm not trying to compare, right? I can say we are doing. I love to see my friend from AWS in here, so on the other side, right? So I think we're focusing on the best support, okay, the Python developer in our cloud. You can see so many out-of-the-box SDK from Microsoft, right, to help you to connect to the cloud more effectively. I can see other side is doing something as well. I can say all the cloud vendor is helping the entire community to doing better, more effectively, because we would like to serve their application to the productions, right? Develop in my laptop is very easy, right? But how do we serve my application? Like something like a very simple Lucky website by Django framework, okay, just like a website or API. You don't want to serve from my laptop, right? In those days, maybe on my desk, in my desk, okay, my server, okay, under my desk, right? Maybe something like this, right? So we try to put all the goodies to help the developer more easily to deliver the application more effectively in a scalable manners, right? I believe other side, okay, like AWS, like Google as well, is doing the same thing, right? To achieve the how the developer more easy to build. I'm not trying to compare, okay? I'm trying to compare the resources, right? Unless we are doing similar.
Thank you.
Yep.
Any other question on the floor?
No, no problem. Okay, just feel free to PM me. Okay, we are the GitHub, okay, Mediums, okay, or see you inside the Discord, right? Yeah.
Thank you, Ethan.
Yeah.
MySQL operator for Kubernetes in Python. MySQL operator is an operator written using Python. So if you're interested in Kubernetes and containerized solution, then this talk is definitely for you. So let's give a warm welcome to Ivan. Thank you.
Hello, it's good. Still morning. Yeah, it's good to speak in here. And Python and PyCon here. So basically, as mentioned, Scott, yeah, we'll go over the container deployment where the MySQL or your applications is likely, okay, going over like the trend. People wants to be more flexible and deploying cloud and more like the layer, which can be actually independent to the vendors, to the platform, and so you have the flexibilities to move around. So how is that actually we can leverage, okay, kind of like KOPF framework, okay, to build the operator, and how this actually apply to the MySQL operator, and then we will see it in actions, okay, in the few minutes. So that's why we try to explore how operator can be created. So to me, my name is Ivan Mar. So as mentioned, I'm actually in Oracle, and yeah, at Oracle, I'm the pre-sales and technical people, and have been actually, yeah, doing a lot of consultings, and yeah, with like Java projects, speaking in like in the past, yeah, Java 1 and things, and also the working with the Asia Pacific, like Sybase, and here's today's SAP, and now at Oracle, and the topic, operator, Kubernetes, container, all these buzzwords. Do you know what that is? Operators, containers. Do you use it? Anyone who has been actually using container? Wow, quite a lot. Are you using manifests, YAML files? Who is using Helm chart? So a lot. What about operators? Do you create your own operator CLD? Yes. Who is using Go for the operator programming? Who is using Python for the operator? No one. Anyone who has been exposed to KOPF? No. So I hope today the sections is good for us to be here. To start with, I will start with the KOPF. Okay, how operators can be written. And then you can actually play around. And then we explore what next with the MySQL operator, how this is being written, and how we can leverage and use it, and why we do this. So basically, as you can see, okay, as a very quick start, what is Kubernetes? It's the container. It's actually quite flexible and really, we want the deployments to be so easy, and that's why there are so many resources. Okay, a port, a container, and some sort of the services and deployment, stable set, status. Okay, all this replica set and all this, they are kind of in the Kubernetes world, we call those what? Resources, right? API resource. Can we define our own? Okay, like what today? We have the PyCon resource, okay, Hong Kong. Can we define this kind of keywords, PyCon, or what we have here? Okay, we can create kind of the CLD. And here, when we create kind of the resources, we need some sort of framework, okay? Maybe, hopefully that will be quite easy for us to leverage, okay? That's kind of frameworks to easily to build, okay? When we create kind of resources, then we can extend those, okay, to do some other things. When we create PyCon, something happened to generate some more peoples or some more like the venues, because once actually the things happen, it triggers some other things to go along. So that's why we need we actually leverage one of the example, the framework in Python. It is the KOPF. Okay, today I'm trying to introduce this. Okay, for the executions, you can see, we PIP install the KOPF and the related dependency packages. And then we create the CRD, custom resource, okay, the data. And then we create the Python code where the triggers, the things happen and the events that happens, and then we want to do something else. So we want to program, right? As Python today. We are trying to build something, what happened after we create a resource? What happened, okay? And then something at the back is like a daemon running and then listens to what happened and then drive the whole things and calling the operators Python code to execute. Okay, that's what I'm trying to put this down, okay? And the execution at the end is you create the resource, and at the end, the background drop, the daemon is trying to execute all this extension and create here the people, value, finding all the volunteers. Okay, you just create the events. You understand what I mean? So you create that, and all this extension will try to go over that. So what today? MySQL, we are trying to create, I want the MySQL to be deployed. And then what else we expect to happen? What else? We may want the resource from storage. We may want the resource to create as like the username, password, secret. We may want some other things, the port, the deployments, and some others like the transparency middle tier where the connections can come in. And all this actually, for simplicity, I just want the MySQL to run. But at the back, some more things to happen. So this is what MySQL operator in here. As like I am here, I do all the job at the back. But as Python, we create kind of all these activities and program to manage, okay, instead of a person to do this. It's the programs to do this. So as mentioned earlier, the CRD. As an example here, I'm trying to create a resource definitions where the name can be a web applications. Okay, I want to create a web. A web is what? A kind of pages, kind of the servers to deploy and run NGX, right? So what this actually we try to say, it is actually namespaces to be deployed somewhere. And it actually contain where we do actually retrieve the pages, okay, from GitHub, for example, from the Git. And as well as how many servers we want to have the load balancing, all this together. But for simplicity, I want the web app and my application in GitHub and then combine them to deploy. This is just very simple things here. But at the back, if I have the operators, which listens to this, and then create all this at the back, how this can be possible right here. So firstly, the CRD as YAML manifest, we just apply, and that CRD should be there, and just right after, we have this. But we have this and what? It just be the definitions, and then nothing happens because of the definition here. Nothing happened. So we want something to happen after this at the back. Someone look at this and check, and we create some other thing, create the server, create the storage, get the Git, and all this, combine them together, and then patches to the latest version, whatever. A lot of things can happen at the back, right? So what we do actually here is, just for example, we can deploy as the resource we did, okay, earlier, apply, and the CRD, we define the resource kind where the demo web, okay? Going back to slide here. If we look at this, we can actually see this. Demo web is the kind, okay? We define here. That's why in here, sorry, when we do this, we actually put this as the manifest, the kind as demo web. And we put the name as just ABC, right? It's just a name. And then we have two properties to set. One is the number of replicas, number of servers, okay? As the number of server, I just defined 2, meaning as the port. We deploy 2 port where Nginx, okay, will be executed. And as well as to get my GitHub, okay, where a static page or a PHP app, whatever, okay, is to be running. So what next is I have the CRDs running. I have this like, okay, the instance, the resource produce the instance, the objects to be executed. What else is the listener? And then at the back, it's trying to execute because of the CRD created. So what at the beginning is to import, okay, some sort of resources, okay, and the packages. And then if we look at this, okay, so KOPF is annotate with some sort of events on create. When we create the CRD, what happens? What happens? It means that there is the functions where we execute. This is the body of all this. Basically, what happens is at the back we deploy another kind of YAML manifest with the servers, with what the informations that we try to put the replicas and also to get the Git resources and put it and combine them together. And then make it run. So at the back here, we are trying to create a YAML doc. Okay, all this just YAML doc, a flat file, and then by passing the parameters with the required informations, and we deploy. And using the API and create a deployment for the replicas, which is the Nginx, and the image, which we define, what is the image? You can add extra and on its own, on your own preference, and tries to create your stuff. So here, just an example, we apply this, and then I'm here to share some sort of the demos in here. So you can see, we get the demo web is the resource. I create this as apply the CRD and the YAML with the kind of demo web. And then we have nothing, the port, because the operator is not running. Okay, so what I'm here is to run the operator as like a daemon, someone stand at the back, and then take up the role, look at what people are asking for. And then it execute and listen to the namespace where my demo, in here, the namespace called my demo. Oh, something happened, okay, the listener, is triggered on create. So when it is created, meaning the whole logic where the YAML doc is deployed, where the deployment of Nginx with 2 replicas, okay, now being executed. So you can see 2 ports as the deployment is running here. So easy. I did not actually create my own, but basically the operator it does, right? So it is quite simple, okay? It's quite handy, easy. So what next is go back. We have kind of the overview of what happened. Okay, what is operator? Because we want to simplify the whole things by means of defining the CRD, and then by triggering all this event and the whole process at the back, we create all these fundamentals and all these foundations where the server, storage, execution, bind them together, back up all this process. Recordings to MySQL, it is more than just execute the MySQL and then run and that's it. No, MySQL has to be run for, quite for long. It has to be stable. When one is done, it has to be restarted. When one actually coming up, it has to rejoin. They may actually clone other data together. So all this happen in here. If we go back, hopefully, I'm trying to move around here. So here, this is the GitHub where you can find the related operator Python source and also the related chart, YAML, deployment CRD. All this is here. The README is here. I'm not going over all this, but trying to explore what happens to this operator. So back to here. look at this. As mentioned, there should be kind of controller. Listen to what happened, right? Listens to what happened. So when we look at this, we see there is actually the KOPF on create. There's also things happen. What happened when we try to delete the resource, remove the resource? What happened if there is something happen to specifically patching or modifying a specific field in the CRD? What happened? We change the version. What happened? Change version means we upgrade. It has to upgrade as like rolling upgrade. Stop one, putting some more images, or there should be something happen. Okay, upgrade is not simply to replace, maybe some extra. Okay, it has to be rolling up, shut it down, bring it back, or it has to be a process to remove, for example, the middle tier, or to disconnect, to migrate client applications from one connection to the other side, just for example. So there are things happen. We need to do the on event for field update, like the version, or actually the router version, or there is actually a CRD listener. There's also when something happened with the CRD, MySQL cluster are being created, the CRD. But the way is, it will generate kind of the YAML DAO, where it generates the pod deployment. The pod deployment on create, on specific event, and as well as the deletions. Something happened, or even health checking. All this, they are actually in the controller. So when we create the CRD, what's inside is like prepare the init config, my.cnf or something from something else. And username, password, or things, prepare secret, and the middle tier router spec, as well as the whole InnoDB as cluster size, where it is not just one instance, but actually a cluster of multiple servers to build HA cluster service, and the services where there are so many MySQL instances running, but we do not want IP1, IP2, IP3. We need a service to be attached to the application, and we just use the service. That's why we build service. So you can see there are so many things in here, stage 1, stage 2, prepare cluster service, and service account, role binding as the administrations, and prepare the cluster stateful set, and what happens to the disruption, and there should be kind of the magic to make sure something happens that should adjust the size, minimum size of the cluster or something happen. So there should be the budget, disruption budget, prepare, and as well as the router servers, deployment, and how's the backup to be done. So all this actually built into here. So if we look at in here, there is here MySQL operator, there is kind of the things to look at this, and there's a controller where we can see in here the controller and the controller script. Okay, the controller script, you can see all these things here. The on create, and what happens with the on create, it tries to prepare all this, a long programming. Okay, what happens to the creations? So back on here. So as the MySQL operator, so let's look at a bit of the demo. So basically, if we look at this, so basically, if we look at this, we may have the namespace. Okay, we can try to create a namespace and deploy a Helm chart. Helm chart where I have some application deployed where we have my cluster in my IC namespace 01. What happens if I want to create another one. So in here, I try to put a script, and basically, it will try to connect to my repository, because the image, which can be public, can be private. So I deploy my private repository for my Docker image, where I need the Docker registry, okay, the username, password, or token, and then I install my cluster with the InnoDB cluster Helm chart and deploy onto my namespace with the corresponding properties where the values can be what? Like, for example, this is an example, okay, where I put in the username, password, what should be the default, my root, what should be the size of the database. Can it be 50 gig, 1 terabyte? So I predefine some sort of information in here. Here, I try to define a 10 GB and tries to define a backup schedule and backing up for every 60 minutes, every hours, and actually I disable it. I don't want to run it regularly and wasting my space. So in here, I try to disable and then to back up to somewhere. And as well as we may define the use of like CPU resources. And as well as some other things, you may want the data from somewhere else, from some kind of the dump file, or actually from another existing running DB, where we clone the DB and into my CLD resources. So this is kind of the resources, and as well as to define like, okay, the time zone, or some other things we can actually define here. So what I can do here is I can run this and put it into another namespace for PyCon today, Hong Kong. So when I run this, basically it's trying to create a PyCon HK namespace and create the secret, and as well as to prepare the Helm chart and running this onto this PyCon namespace, okay? And after this, we will be able to see the port running. The port will be deployed with MySQL servers, okay? So this is actually calling this 3 node will be running. The 3 nodes meaning what? So basically, if we look at the CLD meaning, now I have InnoDB cluster. Get InnoDB cluster is another CLD, okay? And this CLD I'm running in the PyCon HK. So how this InnoDB cluster? We try to deploy 3 instances of servers and 1 set of the routers, which the middle tiers to connect to it. And it is still building in around 2 minutes time, and it will be there. So look at this, it's actually 42 seconds. So, and we look at here's the port. Basically, it's trying to, at the same time, running the initializations and building the servers and getting the image from the external, and all this to build, okay, and maybe another 2 minutes, likely 2 minutes time, the server will be up and running and tie them together to form a cluster, Cluster means what? It means when I update the server on one, the other 2, actually the data will be spread. And they will actually getting the data around this 3 server. 1 server is done. The switching over is automatic. And data is actually not just 1 place. It's actually 2 places. It is reliable servers. Okay? As we see, the server is actually 3 servers. How can we connect to them? Connect A server, B server, or C server? We need a middle tier, the so-called the router servers. So if we look at this, now it is up and running. So if we look at that InnoDB cluster, what happens to this? Basically, it's trying to connect all this together. It's trying to connect all this together and waiting for another like few minutes. Oh, up and running. So the port was running 3 port and now 4 port. 1 is the middle tier. And as well as we get the service, and there should be the connections. How we connect to them. Like the interface. the interface to the server. It is here, the my cluster interface. So what here is, I can execute this and then look at this. And let's say I have the my PyCon. I just create another connections to here. I run the MySQL client and connects to it. So what happens to this is I'm trying to bring up another client Linux image and then go over like the client application and connects to the server. It's connected to the server where I can connect to what should be the so-called service connect. So basically the username is root, where I put in the ISO values, and then what should be the server? It is actually the service where we see this. The service is my cluster. Okay, we just reference by means of the name. Okay, it's like etcd, the name, and the port number we can actually define, and what happens to this? And I know the password, and I'm connecting to it. I can run this, and then show databases, and I can run Python. So here, Python, JavaScript, and all this actually we can connect to the server. And with the, like for example, I try to look at the status and look at the cluster. We can see it's actually running 3 servers, 3 ports, and they are actually on here. The first server, the my cluster 0, my cluster 1, and the my cluster 2, they are actually connected together. I can create database XXX, just an example, okay? And then create table, my table. So something wrong with my, oh, okay. So with this, I can basically, if I want to connect to maybe another server, like for example, right now what the server is the my cluster 1 or my cluster 2, I can connect to my cluster 1. Take this. Difficult to type. So here, we are connecting to the like NOC 2. And if we look at this, and we can see the data is here as well. So basically, we can we insert the data from my table, insert into my table? What happened? Errors. Because the cluster has 3 servers, but one of those in here, it is right. 2 of those, they are read-only, but it's actually scalable. You can actually read data, okay? You can connect and then read the instance data. And it is quite flexible for you, and we can actually use this, and we can change even like DBA get cluster, just an example. And here, if you look at the status, which one is the primary server? It's the number 1 server, the cluster 0. The cluster 0 is the read-write server as the primary. But we can do this to set the primary instance. Very difficult to do a copy and paste. I can copy and paste this, but yeah, how can I do this? Oh, better than nothing. My cluster 1. Yes, oh, no. Yes. And then what happens is here, I can see the primary switchovers. Anyhow, let's come back to here. So the operators, it is written in Python, and it is actually quite simple to apply because we have this simplicity by having these operators running, and you can deploy easily. And with the servers, which we use the stable set as stable, and the storage actually packed with the PVC, and the routers as the status and replica set. And there is also service to bind with the service to attach to one of those routers. And your applications can freely to connect to the My Cluster service. And here's just an example for using manifest, deploy the CRD, apply the CRD, deploy the operators, and also the chart installations, where you add the repository and update, and then install your My Cluster, where you can create your own namespace if it is actually on the web, the GitHub versions. So here more on the operators. As you can see, get InnoDB cluster, you can watch for what is happening, and the services, what IP actually it is connecting to. And make sure one thing, storage. A server has the data putting on somewhere, the storage, somewhere. When we delete a node, we do not delete the storage because the storage is very important. It's your data, okay? So it's actually detached two pieces. One is the application, one is the data, the actual data. You delete the application doesn't mean you delete the data. You can run the same another kind of the versions for the application, for the server, and attach the same data. You just look at the data, physical storage. So if we truly to remove the server, make sure you remember to remove the PVC, the storage, because we do not want you to lose the data. So we do not want to delete the data by just one simple click. Data is very important, okay? You have your own responsibilities to delete your data, the PVC, the PV, persistent volume. You can expose your connections based on the node port, services, or port routings, or even load balancers, or actually internal organizing based on the service which has already been created. Okay, that's all for today. Any questions for now? Yes, please. Thank you.
Testing. Hello, thank you. Thank you so much for our presentation. It's really interesting to see someone here presenting such a deep dive into using Kubernetes with Python as an operator for the CRD for MySQL. So I've had some experience writing an operator in Golang. So I'm not sure why MySQL has decided to use Python as its operator instead of using Golang. What is the main advantage between Python and Golang for using operators, especially for MySQL's context?
Firstly, I would say that we have all this integrated with even Python or JavaScript, okay? We have natively kind of the package, all this up and running. So it is quite easy for us to run Python together with some other interface. Okay, if we build Go, there are only like SQL or something actually in between. There is no extension API to drive the extensions. So that's why Python might be good, okay? And the language like KOPF, it is ready in the market and people has been actually doing a lot. So it's just readiness. We understand people has been, because the first generation, look back a few years back, the operators. The very first version maybe just to Go, right? And thereafter, people also develop some other easy to use framework. Okay, we look at what kind of easy to use framework and what kind of the skill set in here and there. Okay, Go may be the first, but something can actually happen, catch up quickly. So I can't say we we will change. Actually, we have the first generation in the past for the operator. Okay, that was written in Go. Okay, and then we change to use this Python. Okay, so this is like the version 2 already. Yeah, back to a few years back, the operator was written in Go, but that's all gone. So when we develop things or doing something, there are a lot of things constrained around us, right? Constrained no matter this is resources, this is how you use, and also what we have at the back. So all this together, maybe we designed that this is the best for us, okay? And also for the people to work with what it is, because it's easy to use.
So any other question from the floor?
I think time is up, right?
We have some time. Yeah. So any other questions?
Okay, so thanks a lot.
Okay, so thank you, Ivan. Okay. So before you guys go, actually, we are going to take a group photo. So if you don't mind, please stay on your seat for a few minutes, and then the track 2 people will come back in the same auditorium, and then we will do a group photo. Yeah, thank you.
Yeah. Just so everybody will come here.
Yeah, they will come back here.
Yeah, sure.
I think this is good. USB-C.
You have Type-C?
Yeah, Type-C.
You do?
MacBook.
And if you need, so we have downtime.
waiting for the other room to end. We are very grateful for everyone to come. This is finally we organize a physical event, and I already talked to many old friends, and I hope that you will meet some new friends as well. 係啦，咁啊唔該晒多謝晒各位嚟啦，無端端講翻廣東話，係啦，咁如果可以嘅咧就可以坐埋少少，等我哋影相嗰陣時就即係好睇啲，係啦係啦，係啦向中間係咯，睇下嗰邊得未先？應該都嚟緊嘅，嗰邊應該唔會遲㗎啦。係啦，嚟緊嗰啲。麻煩大家坐中間少少啊。Please take a seat in closer to the middle, and also please come forward。係啦，第二行冇人坐喎，嗱，有位阿朱生就好好啦，係啦，咁啊，我就得啦，坐晒先啦，坐晒先啦。 So now we start our afternoon session. So first I would like to introduce our speaker, Mr. Fortune Hui, and then Mr. Fortune Hui is a solution architect at Amazon Web Service, and he specializes in data analytics, designing serverless data platform, data warehouse, text analytic platform, and etc. So prior to he joining AWS, he engineered data pipelines in various industries, including retail, aviation, and insurance. And then I think everyone can now see that he's going to introduce to us accelerate data preparation with pandas and AWS Glue Data Brew. Okay, so without further ado, I would like to invite Mr. Fortune Hui.
Okay, thank you very much. So hi everyone, I'm Fortune Hui. I'm a Partner Solutions Architect specialized in analytics in AWS. So today I'm going to share something about data preparation with pandas. I know you guys are all Python developers and Python lovers. You should be very familiar with pandas. And so besides that, I'll also talk about Brew, Data Brew, which basically is a visual data preparation tool. Before I start the session today, can I ask a question to the audience? How many of you have used AWS for whatever reason? Maybe, can you raise your hand, please? Wow, happy to know that, majority. So how many of you have been in the field of data science or data engineer in any services, like not only in AWS? Please raise your hand. Okay, so I can see a few of you are. So I hope I can bring you something new to share with you something about data, machine learning, like the analytics side and the ML side of the stuff. Okay. So as for what to expect from this section, I will be sharing a little bit on AWS and machine learning. And then I will share with you data preparation and how pandas, I mean, we release a SDK for pandas that could get connected to our AWS data services. And finally, I will talk about Glue Data Brew, as I just mentioned. Okay, so a little bit about Amazon. At Amazon, we have a very long history of machine learning and driving innovation with machine learning. ML is an integral part of Amazon. We have been applying ML in areas such as personalization and supply chain for more than 20 years. We have also improved our original personalization model and significantly over time and move it to other products like Amazon Prime. We also use ML for our fulfillment process, including developing a forecast system that can predict the appropriate amount of demand for each product we sell worldwide to deliver on customer expectations of convenience, cost, and delivery speed. And we have developed some NLP, natural language processing technology, to give our customers an entirely new way of interacting with technology through Alexa. That's the blue appliance like here. And we have also developed a groundbreaking technology such as autonomous flight through prime air, drones, and robotics in our fulfillment center to get packages to our customers faster. So almost every department at Amazon has been touched by machine learning. So apart from cloud computing, we are also bringing our machine learning experience to our customers. So a little bit about AWS. AWS, Amazon Web Services, is a vendor of choice for over 100,000 customers and a leader in offering the broadest, deepest compute infrastructure of AI ML training and inference. You can choose from a range of Amazon EC2 instances based on the latest CPUs, GPUs, and custom accelerators, coupled with industry-leading networking and storage to meet your budget needs and the performance requirements of your models. And AWS is investing and innovating to deliver a range of high performance and low-cost infrastructure options, so you can choose the option to fit your need. So some example, AWS is building silicon from the ground up that is optimized for ML inference performance. So what I'm talking about is deploying the model. And we have used our learning from our Graviton CPU and Nitro system innovations to build the AWS Inferentia chip. So basically, it's a custom chip that delivers the lowest cost in inference in the cloud. So besides that, we also have released our Trainium chips that is optimized for ML training, and we offer EC2 instance that make use of that training chips. So basically, high performance, low cost, easy to use infrastructure services to train and deploy ML and deep learning models. So I'm gonna share a little bit from a perspective what machine learning is. So we actually have a machine learning white paper talking about our view and our perspective in machine learning. So basically, the life cycle, it starts with business goal. So after we talk to our customer, we understand the business problem and identify the business goal, data scientists try to frame that problem into an ML problem. So whether it's a regression or classification problem, or maybe a deep learning neural networks required. And then we start looking at the data. We collect the data, process the data, we do feature engineering, and then after we extract the features we want, we start building, training, tuning, evaluating the model. Like after the model's ready, we get confirmation with our users, and we deploy it to the production environment and keep monitor so that the model is retrained regularly to keep the performance. But then throughout various steps in the ML cycle, according to a Forbes study, like 80% of time of data scientists is spent on data preparation. I think, I'm not sure whether you guys echo. I mean, I was a data engineer helping data scientists, and I fully understand because that's my job. Like I made even from that job, and I can really see why, because like data sources is scattered everywhere. Like to get the right data, there's logistic effort. You have to identify the right system, and not only system, you have to identify the right owner. Throughout the corporate, the responsibilities also scatters with the system. And then you need to do some paperwork for applying access and ground permissions. And you need to sort out something about the networking. You have to connect to the data source to download the data. And there's a technical effort that you need to find the right API and SDK to really download the data, to play with the data. And then there's an analysis and engineering effort, like you have to study the data dictionary. The data dictionary may not be accurate, may not be up to date. And you have to do the profiling for all the 2,036 columns. And then after all the effort, you found there are so many cells that have no value, and you have to cleanse it. That's a lot of work. I understand that. But however, like data is the key. Garbage in, garbage out, we all know that. So I think that's why we're willing to spend so much time on data preparation. But I think as a developer, as a data engineer and data scientist, we hope there's something that could help us leave this tedious effort. And speaking from a data engineer and the ETL developer perspective, I can say that data preparation is actually required for different persona. Like not only data engineering need to do data preparation. Like if you're a data analyst, you may need to develop different kinds of dashboard, and you may have your specific need. You need the data aggregated in your own granularity, and maybe sometimes you need to do some joining, so you'd have to unify data from different data sources, some in different kinds of databases, and you have to prepare your own data model, so it serves your dashboard's performance requirement as well. And then for data scientists, it's a tougher question because often the time when we are inputting data in a model, you need some types of data science specific preparation, like you do some one-line coding to turn the category value into numbers, into bits, so that the machine model reads it well. Maybe for some value data, you need to normalize it, put it in a scale so that Yeah, and that's a requirement of training a model. So basically, every role needs to do data preparation, and yeah, that requires quite an effort, and to fulfill different analytic needs. And so what this AWS has in here is, first of all, we offer a purpose-built data sources and analytics service that best suits the transactional and analytics use case. So first of all, graph databases, they work well for storing and navigate relationship. It's basically for connected data. So it's perfect for customer 360, for fraud detection, and some whatever use case you need to navigate through the relationship, you can make good use of a graph database. And for text search, or maybe sometimes you need to do analysis on log files. Yeah, you need to you could make use of open source services that put the text in inverted index, like called Lucene. So it speeds up the text search. So it's good for operational analysis and SIEM. Time series data, obviously for time stream database, it's good for predicting some financial trends and monitor healthiness of applications. Structured data, I guess you guys are really familiar with that. I won't go deep. So for DynamoDB, it's very popular kind of DB that stores, like game dashboard, some web app, very common in modern web application. And of course, unstructured data like audio, like video, you store it like in the data lake. So these right to accelerate data analysis. Like you can answer questions like which person are related to the people who is interested in a particular product. So these are questions is easily answered by navigating through the connected data structure in a graph database. But if data is stored in a SQL database, then you need to join the same table for several times to write very long queries. That might not be the most efficient way to find answers in those data sources. But we are Python writers, right? We're developers. So our tool, the data community loves Python and pandas. So we use PyCharm, we use JupyterLab as an IDE, and with the Python language, there are various libraries that we are very familiar with. Scikit-learn, Seaborn for the graph, NumPy for numerical calculations. So what we have to do to get data from these data sources, write a script, find the API, find the SDK, and different kinds of database. It might require some development effort. So before you even start your analysis, you have so much effort to get the file into your local environment. Not to say you have to worry about the storage, because although memory is cheap, your laptop has limited storage. So it takes time, it takes effort. So AWS is an advocate for open source, and we understand this requirement. And therefore, we develop a SDK for pandas to connect to these AWS services. So for AWS SDK for pandas, it's an open source Python package. So it's built on pandas, Apache Arrow, and Bottle3. So Bottle3 is a Python SDK for accessing our services, but we abstractize this layer so that with a few functions, you can easily connect to our data sources and execute usual ETL tasks. You can directly load this data from our data service to the data frame, and then you start to use the libraries that you're familiar and start your analysis and engineering. So it integrates with almost all our data-related services. Like just now, I mentioned some of the types, say GraphDB, TimeStream, some relational database. Some of the things that are worth mentioning is Athena. So this is our interactive query service. So basically, with that, you can offload some of the calculation effort to Athena. It helps you filter data on S3, return result that you need to your data frame to offload some loading from your computer's memory. And then it supports connecting to PostgreSQL, MySQL, SQL Server, this kind of generic database as well. So basically, it saves effort for connecting to this data source. So everything starts from the data frame. So how do we use it? So if you are using AWS Lambda, you just need to create a managed layer, just an execution environment. We have a managed layer in here, which you can use. And if you are using our serverless ETL tool called Glue, then you just include the Python the library real file in the S3 library path. And if you're using our big data managed Hadoop ecosystem service EMR, you could add a Bootstrap script before you provision the EMR server to just do a PIP install. So I think for the most for idea that you guys are most familiar, like on-premises or local environment, you could just use PIP and use Conda to install the package, and then you can start using the service. So just a highlight of the function and feature highlights. It basically can read and write data on our S3 bucket. So it's low cost and performant data lake storage, object storage. There are also some functions that you can merge and upsert your database in Parquet format. You can also directly connect to open source service. If you guys are familiar with Elasticstack or OpenSearch, often if you read data from OpenSearch, you need to write DSL. So basically, it's another syntax, but it supports SQL query to reach OpenSearch. And then some interesting thing is you could also get to our CloudWatch log. So basically, CloudWatch log is a AWS service that you could keep all your server logs and the service log for your analysis, and you could directly connect to CloudWatch log and load the data in a pandas and start analyzing as well. So I just mentioned some of the features, cover some of the features here. You could also feel free to go to our wiki and official documentation for more different the full set of features. So this is the first part, connecting to the database. So what's the second part? The second part is to actually go deep into the data set, to profile it and cleanse it. And then the next step, we have to orchestrate in scale, because often we are not dealing with just one or two data sets. We may be dealing with like one or two databases, and each have like 50 tables. You have to repeat your profiling work many times, and you have to schedule it, make it regular, deploy in production. Python works, but sometimes, again, it takes effort to perform these tasks like repeatedly. So you need heavy lifting. So I would like to introduce AWS Glue Data Brew, which basically visual data preparation tool that help clean and normalize the data up to 80% faster. So as you can see, there's a nice graphical user interface for you to do your own data preparation. So it generates data profile for you for each of the say string column. It gives you a distribution. It tells you correlation of the features. It provides some special functions for you to remove outliers. And some feature engineering functions say it has built-in transformation. It has around 250 built-in transformation where you can do one hot encoding, where you can do normalization, etc. and etc. And it also supports Jupyter Notebook, so you can use it within our Jupyter Lab. So there's a plugin you can install, then you can use the tool without leaving your environment. So I think these 4 points, it wraps up the features of Data Brew. So it helps you understand the pattern and of your data set. It runs automate tests, and then you can schedule it to run regularly when your updates of data set arrives. It has built-in transformation for user tasks, and also it helps automate this, like using our other scheduling function. So I would like to share with you some of the popular use case for how to use Data Brew. So this is architecture where we recommend our customer when they need to set up data quality rules. So basically, when data arrives at S3, we can set up data quality rule in Data Brew. If anything happens, it sends a notification to with our SNS service. It sends you an email to notify you. So, and another common use case is you can do data preprocessing for machine learning. So basically, when data arrives, we can sense an event and trigger a Data Brew ETL job. After it finishes loading, it writes into output bucket where the data could be fit in our Jupyter environment for model training automatically in SageMaker. So I think I'll have a demo for you guys to see the SDK and the Data Brew. Okay, so basically I'll be using a SageMaker Studio notebook environment. So this is a one-click environment where it provisions a Jupyter Lab-like IDE here. So you can use different kind of cluster. And instance, I'm using a ML large instance, and you can use these GPU environment as well. So it comes with a specific price list. You pay so you pay on your own demand, and also you can select different kernels like execution environment. Say now I'm using a data science image, and you could select like base image using MXNet and some other built-in framework support like PyTorch and TensorFlow, and you can also use Spark as well. It supports PySpark and Scala Spark. And you can also bring your own container image as well, but I believe that should be quite enough for usage. So, and also when you could just navigate the folder structure like you use in PyLab. You can connect this environment to a GitHub environment to do some version control. And then you could also, this is the other component of the SageMaker. And also you can install plugins here. Yeah, say in the plugins, this is the Data Brew plugin I'm talking about, so we'll share later. So we can start navigating in the library itself. So basically, one line PIP installation will be fine. Then we can try execute and see the version. And at this time, we will be using an Amazon customer review data for tests. So with this command, like this is list directories, we can check our data lake path. So the dataset offers Parquet format and TSV format. We'll be using Parquet format this time. And then we can go ahead and have a look at the folder inside. So it's already partitioned by different product category. So today we'll be using a baby data, baby products as an example. So we can use this size object command to see the around 490 megabytes data. So we can go ahead and execute this command and read the data into our data frame. So after this one line execution, it will take some time because after all, it's a medium-sized data set. So so this is the data frame I guess you guys will be very familiar with. It has the marketplace, so where the product is host on, it has customer review and product ID. It also has some product title, ratings, votes, and also some review body and review dates. So basically, this data set is free of charge. It's online, so you can also use it to test it if you want. So I think the rest, you guys are familiar, just some ordinary pandas data preparation steps. You can check the columns, check the shape of the records. You have around 1.7 million records with 15 columns. You can also check the number of unique values of each field. Yeah, you can see there's some duplicates here as your review ID is different from the number of records. I've done some profiling, so I can drop duplicates using pandas command. Yeah, and then I can also check the dimension. This is a common operation, so we know the data comes from these 5 marketplaces from Europe to US and Japan, and it has different years of data. And also null field, our enemy, we know we can check that using this isNull command, and then we can go ahead and check some basic statistics of numerical columns. Yeah, and then after that, pandas, also we can use some other libraries to check, the correlations of different features, and we can easily visualize it using Seaborn library, like this. So as you can see, with this SDK, you load the data in data frame, and you can reuse every libraries you have been using, and start quickly to deal with our data sources. So the next thing I want to demonstrate is what next. So say, for example, you have already finished your data cleansing, and you need to write it to output bucket. So I think one of the good points of this SDK is with one command, you can output the data into the object storage and register it as a table in our Glue data catalog. So I think I will spend a little time to explain what is Glue data catalog. So basically, it's a technical data catalog where you can register your data set in your object storage. So that you can easily reuse it without remembering the path and metadata and schema. So I will go ahead and just create the bucket and the data catalog database first. And I've already created, so I'll just skip it. Okay, so the Glue data catalog, it looks like this. So it consists of logical databases to hold different tables. This is the table I register. This table, Amazon product review package, points to this S3 location. And inside the data set, you can see there are the path, there is input format and output format, which is using package. And then it automatically registers the schema, like different column names and types, and also the partition. So this is a schema. So basically, it's the same as what we see just now. And then you can see you also register the partition by product category. So all the data metadata is registered in the Glue data catalog. And the next time we want to connect this data set, we just connect to the table. So we go ahead and execute a command to output the data to S3 bucket and also the catalog. So as you can see, there are several parameters you can choose. Say you can assign partition column. You could assign the compression, like this is a snappy format. And then you can also set this concurrent partitioning, where it triggers a parallel job so that you can write your partition in several threads. It speeds up the operation. And also you can specify which Glue database and which table, the name, you want to register a table in. And then after writing, you can use this catalog table function to display the schema of the table, okay? So after writing, we could also have a look at the S3 directory. So it looks like this. So basically, it follows a high metadata partition format. And then this file line of code, it demonstrates how you could easily read the table from Glue data catalog. It takes some time because the data is quite large. But then if you are using Athena, which is our query service, you can enjoy some predicate push down, where the Athena will grab the data in S3 for you finish the calculation result, and then it returns only the result to the data frame. So you can see the time is much quicker, it's 3 seconds, because yeah, Athena does some of the effort for you. Okay, so this is basically the demonstration for the Python SDK for pandas that you guys are free to explore. Okay, and I think I will just quickly jump to some snapshot of the Glue data brew. So it's something like this. So basically, after one click, you import your data set, then it gives you automatic data profile. It shows you, for example, the string column. It gives you the distribution for each of the values, and it tells you some, it tells you some basic statistic. Oops. Yeah, and for transformation, you can also enjoy some of the built-in features. I think I will just highlight. I'll highlight this. Say if you have a category column and you want to do a one-hot encode, you can just do a one-click, and then Glue Data Brew help you generate this column. So it without a line of code. And also for some general operation like data type change, and also say for example some splitting with a delimiter. This is also available as well. So I would say it's quite handy. So it saves effort. Like especially you imagine you have like more than one data set. You have so many data sets. Then you can also automate it using code. So it helps work on that for you as well. Okay, because due to the time limit, I won't be sharing the whole sharing on Data Brew. I want to wrap up this session with some cloud. So if you want to try the SDK, you could go online and search the name, SDK for Pandas. And just now, the SageMaker Studio environment, we have a SageMaker Studio Lab IDE, which is similar, that you can go on top. So it offers you 15 gigabytes free of charge for storage, and around 15 CPU, 15 hours of CPU and 4 hours of free GPU environment. Okay, so you can experience or have a try of SageMaker Studio. And also, we are hiring. We are hiring associate solutions architect. So this role is for graduate 2023. We welcome full-time bachelor degree fresh graduate in 2023. So if you're interested, please go ahead, scan this QR code, go to the website, see the details. So I hope you guys have enjoyed the sharing today. Thank you very much for your time, and have a nice afternoon. Thank you.
Hello.
Thank you for your presentation. I would like to ask about the Data Brew. Do you have any visualization tools, such as if, for example, I'm doing a linear regression, and do you have visualizing the data so that I can find out the outliers, and then I can remove the outliers of the data? Thank you.
Okay, thank you for your question. Data Brew is for data preparation, so it's a visual tool. You can do ETL, so transform your data set. If you want to perform like linear regression and you want to visualize the result, there are two ways you can go. First of all, SageMaker Studio, you could use Seaborn to visualize. So this is the cheaper way. And as in SageMaker, we also have built-in function. We have something called a data wrangler. It's another data preparation tool for ETL. So it has built-in function for doing a few checking. Say, for example, the linear regression, we have bias check to see which column whether it's skilled, and also several quick model building capability. So I would say it's not in Brew, but SageMaker does offer different features for what you want.
Okay, one more question. Anyone would like to ask? Okay, so if there's no question, I would like everyone to give a applause for Fortune Home. Okay,
thank you.
Thank you.
OK，大家留意啊，嚟緊呢個 session 咧會係英文去，即係 speaker 會講英文嘅。Let's start our next section now, and then this is Mr. Woodhatch, and then from Deployify, and then I would like to pass the time for him.
Thank you. Thank you. Okay. Is my volume fine? Yeah, cool. Okay, thank you so much, everyone. Thank you for inviting me. Thank you for having me here. Today in this talk, I'm going to share a little bit about doing machine learning on the cloud. I think a lot of speakers in the past today already have talked about doing machine learning on SageMaker from fellows at AWS, and earlier in the morning from Microsoft as well. So I'm just going to talk a little bit on a different note here, where I'm going to go machine learning more sort of in a custom way, coding it out yourself. It's going to be a little hands-on, so if you have any questions in the middle as well, I'm okay to stop and explain. And then later in the talk, just talk a little bit more about how we at our company do machine learning on the cloud and how we make it quick and scalable. So a little bit of background about myself. I graduated from HKU as a computer science bachelor's student in 2020, and then since then I've been working on a number of projects. I've been working on my own startup called ClearBot on the top left. Right? It's a robot that cleans the oceans, and a lot of my machine learning experience comes from there. And then later on, I also started working on a project with a couple of my friends called Deployify, which is basically aimed at making machine learning for the cloud simple and scalable. Right? So if you're wondering if this talk is for you, well, if you're just getting started with Python or machine learning, right, maybe this talk can sort of help you appreciate what you can do with Python, right? And if you're just getting started on machine learning, or you're thinking whether you should use Python for machine learning, hopefully you can get an idea of how to do that, right? And hopefully I can bring you along in my learning journey for doing machine learning on using Python. Well, if you're a little bit more experienced in the field of machine learning, hopefully this talk will help you sort of understand my own experience and journey with machine learning, right? And if you're using any of those tools, just help you appreciate how machine learning can be used for social good, which is where sort of my motivation for machine learning comes from, right? So to break it down for you, my next few slides are just going to be starting with what is machine learning, right? For anybody who doesn't have a solid idea about it. And talk a little bit more about why I build machine learning on the cloud, right? And then come to a very interesting application of machine learning with, for social good, which is battling deep fakes. It was a thing 2-3 years ago as well, and a lot of efforts have gone into battling deep fakes. And hopefully I can do a little programming session, a live demo, which may be available on your phones as well, to sort of detect deep fakes live over the cloud. So starting with what is machine learning, right? So for somebody who's sort of just getting started, machine learning might seem a little sort of daunting, but at the end of the day, machine learning really is just a lot of mathematical models at the crux of it, right? This image is from a very popular Coursera course from Andrew called Machine Learning Specialization, right? And it goes really deep if you ever want to get started on learning machine learning, just on the basic concepts of it, right? I've personally learned a lot from it, and I highly recommend this course. But well, machine learning, is something you can even do on your laptop. If you think about it, if anybody of you here have done machine learning, you'll know that simple libraries like scikit will usually have CPU compatibility. That means you can run normal regression models on your own laptop. A lot of times you can buy GPUs, right? And and you can even run some very complex sort of models on your own desktop or something if your laptop has a GPU. But then why do it on the cloud, right? Because doing it on the cloud is not cheap as well, right? Not saying that buying GPUs is cheap, but a lot of times when that machine is not owned by you, you feel like it's expensive. So let me try to help you appreciate why doing it on the cloud sometimes might be simple and sometimes cheaper as well. Think of a machine learning model such as this one, right? This actually is directly from a paper, YOLO, for those who might be sort of well-versed with the object detection field. This is a fairly complex model in the sense it has multiple layers depending on what size of the model you're using. But these kind of object detection models are usually used in applications where you're running it on a robot, for example, where we are doing it in our company, right? And a lot of times these robots or like smaller devices don't really have the compute power on them, right? And that is when you would want to run it on the cloud, right? Given that it's going to run faster over there, right? And actually, YOLO is one such model which is supposed to run real time, given that it has a GPU to it, right? And what it does is it detects a person, or essentially it does bounding box detection, right? But sometimes you have to go beyond even those complex models that might still fit on your GPU, on your own computer, but go more further into heavier models that may not even fit on your GPU anymore. So this is actually directly from a paper as well, from deformable transformers, which is object detection for novel classes that the model has never seen before. So when you have a completely new class that the model has never been trained on and you only have 10 to 15 images, you use embeddings from the previous classes and try to sort of train the model for newer classes, right, using very little data. Now, these kind of models actually are really, really heavy to an extent that, this is the recommended command for running this, this training. And the real part that I want you to notice is that it uses 8 GPUs on one computer, right? And actually that 8 afterwards is because it is using 8 such VMs that are running on, that are using 8 GPUs. And the documentation for this paper, the code that comes with this paper suggested that each of those GPUs is a NVIDIA V100, right, which is already thousands of dollars racking up, right? Whereas if you rent the same kind of machine on GCP, for example, or AWS or Azure, and you're going to run this training for, let's say, even 24 hours, it's going to cost way less than that, right? So hence, doing it on the cloud, doing such kind of trainings on the cloud sometimes makes sense because setting up such hardware in your own office or in your own house is sometimes just not feasible financially. So if I can sort of get your sort of appreciation on why machine learning is done on the cloud, then finally moving on to machine learning for social good, which is actually very much sort of my motivation behind doing machine learning, right? So actually, this is one of the models that I very closely work with on a day-to-day basis, and it's based on this data set called the Taco data set. It's a data set which is labeled for different kinds of trash, right? And this object detection model, we kind of use it in our company for a very specific purpose, but to help you understand, actually this object detection model for trash can be used for a lot of different use cases like recycling, trash sorting, tracking and accountability of what brands are making this trash and so on and so forth, right? So there are a lot of applications of a very simple object detection model for this use case. And we use it for our robot, right? So this robot is actually collecting a lot of trash. This is from Wanchai, in Wanchai Basin, right? And this is actually the amount of trash that shows up every day at that basin. And we're not just collecting this trash, but also tracking how much of what kind of trash is there in the water. And and hopefully, give some tracking and accountability so that this trash can be reduced in the water itself in the first place. So simple applications of machine learning can be used for social good, can be used to improve our lives. Now, this is a more sort of serious application, but what I want to do is something a little bit more fun, which is talk a little bit about deepfakes. Has anybody heard of deepfake? Right, a lot of you, right? It was pretty popular. There was a video of the President of the United States giving a speech, and I thought it'd be fun to plug it in here as well. If this video works. I will try to pause it before if there's audio, because not all of it is kind of appropriate. So I'll just pause where can there be audio? Or if it's not, then the captions are okay. Right, so here is yeah, that would be great if you can get the audio.
Carson is in the sunken.
Okay, I don't want to blast anyone's ears, so I have to reduce the volume first.
In which our enemies can
okay.
Try to switch the audio output. Okay.
Yeah.
Should be. It look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place.
I'll just pause here. If you want to kind of watch the video after this, I would not like to play it on stage, but you can go ahead on YouTube and search for "You Won't Believe What Obama Says" in this video. Essentially, this was a problem. I think this video was posted back about 3 to 4 years before COVID and everything happened, and this had become a big problem, right? So. Then the problem became, can we use machine learning that was sort of being used to generate these videos to also detect whether these videos are real or fake? And hopefully, and I will not guarantee this, that it might also work on your phones. It's running off my laptop and a few free servers on few places. But if it does work on your phone, I'll be happy. If it doesn't, I'm really sorry. I'll try to demonstrate it on my laptop itself. But before I actually get into the code, I want to talk a little bit about how I've built this. This is not probably the best way of kind of implementing this, but it works. And it's straightforward, right? So we have a browser on the right? And this would be your phone or your laptop, right? And step number 1 is that we need to upload a video somewhere so that it can be processed on. So I'm using AWS S3 here, and uploading the videos that are recorded on the browser up to a bucket. And then at the same time, once that upload is completed, I send a request to a GPU server that I'm running on GCP, I think, right? And this once I send this request to run a prediction on that video I just uploaded, the server downloads the file from S3 and then returns back a prediction, right? And all of this I've deployed on a Docker image. For the GPU server, it's running on the Docker NVIDIA runtime, and this website is running separately on a Docker image on one of the popular deployment websites I'll show you later. And finally, to bring this together, sort of to build the API, I'll be using something called Fast API. And I'll only try and demonstrate the server side of things and not the browser side of things, because this is PyCon and we're talking about Python. If anybody does want to know a little bit more about how the JavaScript side of things is done, reach out to me and I can share the code with you. Cool. So let me see if I can just go to the code first. I just want to quickly check if my server is still running. Cool, okay, it's all running. I was just playing around with this before coming here. So this website is actually deployed on something called Railway, which is quite a new website. But I'll hide myself first. Okay. Okay, cool. So what this app does is, before I get into the code again, a little bit about what this app does, is it uses the camera here. The idea is, imagine a more real-world application where you could point your camera to an already playing video on a screen and check whether it's a deep fake or not, right? And okay, I think you can see this. So I'd just like to show you a demo and then maybe show you how it's built. Let me see if this works. Okay. It just records a 5-second video and it's going to repeat it, so I'm just going to move it because it's weird for me to see myself. Okay. I hope it works. Give it a little bit. It's kind of uploading the video, slow internet. It says it's 53.91% fake. So it thought that I'm 53% fake. Now, anybody has any guesses what went wrong? Please, go ahead.
One, the camera is on high resolution, and two, you're wearing a mask.
Yes, and that's actually the biggest problem here. The camera is actually, the trained images and videos on this are actually 480p, so the resolution was okay. But actually, I'm wearing a mask, which is a big problem for this model, right? Because when this sort of model was built, it was around 3 to 4 years ago, and as I said, it was before COVID and all happened, so nobody was wearing masks. So it was sort of a biased data set, right? So with my mask on, it says it's 53% fake. I'd encourage you guys, if you know, yeah, sorry, go ahead.
For clarification, I think in most data sets, they don't anticipate you wearing any mask.
Exactly.
Not
Exactly. That's great, right? So again, you can try it yourself when you're in the washroom or something where you're allowed to take off your mask or in your own room, and then I'll share a link to this and I'll keep it up for at least a day or two. After that, I can't afford it, so I'm going to shut it down. But until then, you can give it a try, right? So that's the idea. Cool. So let me pull up the code to show you a little bit about how it's built. Okay, no secrets, nothing. Okay, cool. So as I said, I'm using Fast API to build this. It's a little bit of these things I've sort of refactored out, so you don't see a lot of the complex model building things, and that's usually not the point, but let me do this. So actually, I'm connected to a GPU server. You see on the bottom here, it's a remote connection. This is using one of the servers that I have built somewhere here. So this is actually one of these servers. right? So it's like a small GPU instance which is deployed on GCP, right? And you can connect to it and stuff. Where is it? Cool. So just let me try and walk you through this code. So we import some very basic stuff like fast API, right? And we create an application out of it. We are going to download images from download videos from S3. So we import Border 3 for S3 side of things. And these are some of the model tools that I sort of just compiled together, right? Which is here. It's a little more ugly looking, but it's essentially loading a bunch of these weight files and running an evaluation on them. Sorry, not here. Running an evaluation on them, right? But here, I don't know if you guys have worked with, if you all have worked with, web applications, but CORS is usually an issue. Don't do this on your production applications because you're basically allowing everybody to request your API. But for this purpose of this demo, I guess. And then I'm expecting a request from the client, calling it a video request. And all I'm going to take from the browser is a file name, because the file has already been directly uploaded to S3, right? So I don't need to really stream the whole file over the HTTP network. I just need the file name that I'll download later. Cool. So I make two routes. One is to check before coming on stage whether my application is running or not. So just to check whether it's working. And whoa, this is very buggy. And the second one is predict, which basically runs the actual prediction. And you'll see in this predict step, there are just four. In this predict function, there are just 4 basic steps. One is download the actual file, right? Which I'm going to get from the request, right, with the file name. And then run a prediction on it using the model that is hidden away in the other files, right? And then just log the prediction here. So when I ran last time, you see the prediction was 0.539, right? So that's running the prediction and logging it, and then just returning a result back to the user, right? And that's what you see on the browser screen with prediction and so percent. And going a little bit deep into how you download the file. So as I said, the browser side of things, I can make the code available. It's pretty straightforward after this talk. But once the file has been uploaded, actually downloading the file to the server is straightforward. You just create a S3 client, give it some credentials, and then after that, give it a download path, right? So I'm going to download it in a very specific path here, right? And you'll see that all the files that I download are actually going to show up here, right? So as we process them, this is actually one of the storages on GCP, and I'm just dumping them all there. So it's available on the cloud as well. And then I just download this file using the S3 client or download file. I'm sorry. And I return the download path so that I can run a prediction on that. Running a prediction is simple as setting up a few parameters, frames per video, that you want to start doing some prediction on. Extract the face, so this deepfake runs on faces, right? So if you put up actually something else in front of it, it will not work, right? Like I don't know, a sheep or something, right? It won't work. And then there's a very simple handy function that I've built called predict on video that takes these things and just runs on the video. Runs the prediction on the video and returns a value. So yeah, I think this is as simple of a walkthrough as it gets. I've shown you the demo already. If you want the link to the demo itself, you can find it on my GitHub profile. Actually, it's public, I believe. And if it's not, please do reach out to me. Right. And that sort of wraps up my talk. Thank you so much for listening. This is our company, Deployify. You can scan the QR code and use the platform that I use to spin up the GPU servers and stuff. We are basically available for free at the moment, right? So you can create an account, log in with GitHub, and just create as many servers and stuff as you like. Thank you so much for listening. Yeah.
Sure, guys. We got some questions for you, Mitash.
Okay, so thank you for demonstrating the the API server in Fast API, and I believe that Fast API is more production ready than Flask, and it is better than Django. But I have found some flaws, something that it may be can be used so that the performance of the server can be better. So can we go back to your code?
Oh yeah, sure.
Okay. So one thing that concerns me is that in the predict endpoint, so the download file is actually a synchronous version of downloading. Yeah. So I think because when you run async, then you only have one thread and running in the event loop. So the download file, I'm not sure whether it is blocking or not. So is it better to make the predict into not async def, but just a synchronous version? Or maybe we can use the AI Boto 3, the asynchronous version of the Boto 3 client so that we can increase the performance?
Sure, that's a great question. So actually the download here is a blocking request, right? So this download file function is actually going to block the rest of the process from happening. So that's why I said that if you guys actually give it a try right now, and when I'm trying it, it's gonna actually block your request from coming in, right? And it's valid that this code actually could be improved by making this process asynchronous. If you would like to hear my take on it, I would probably just add another route here, because I still would need a route requesting to run the prediction on a file. That means downloading a file and generating a result on it. But then I could keep that result here on the server, and when the user sort of polls on prediction result or something, and just and I could just simply return something else, so saying, right? I could make something as simple as that, so that when the user keeps polling on this result, obviously this is also not an ideal version of this, but I would just split this into two requests to make things more asynchronous, so that one of them is a job sort of request, and the other one is a polling request to ask for the prediction result, right? Something like that.
So do we have any more questions for Mr. Ron or Tash? Please raise your hand.
What video formats are supported?
Actually, this one is just supporting MP4. I squeezed in some time to build up this demo, so at the moment I just have MP4s on there. But it's really versatile in the sense that on the browser side of things, if you upload multiple formats, it should work just as well.
I noticed that you're using VS Code Remote to SSH into a server. Is that the same server that's actually the model is deployed on? Because I also see some logs here. So could you expand more on the architecture of this demo?
Yeah, for sure, for sure. So maybe I'll just close this remote connection first. Thank you so much for the question. It allows me to demo a little bit more about this. So I actually have a VS Code extension that is built alongside with Deployify. And you can, so I'm using this workspace, and I can just connect to the server, right? So it's like a direct connection, SSH connection to that server. Now on that server, yes, it's the same server that has deployed the machine learning model as well, because I developed the model on this and then trained it and then deployed it using Docker, So to actually make a deployed version of this application, I used a Docker file, and it's running in the Docker runtime of the server itself, right? So the actual setup of Docker, for those who are not familiar, you have to provide a base image, right? We're using the PyTorch runtime image, which has CUDA and CUDIN enabled, right? Because we have a GPU server, we can actually run it in the NVIDIA runtime, right? And install some basic dependencies to run, video processing, and some of the weights that are needed to run this model. And then I just installed Fast API, OpenCV headless, because we need it for processing videos, and some other libraries, including Bodo3 and FaceNet, which are required for my code, right? And then I have a run script which runs when this Docker container sort of starts up. And it's as simple as just starting a UVcorn app, which is a HTTP middleware sort of server that allows me to accept requests, right? And yeah, all of this is built on a Docker image which is running here. I can give it a go. So it's running as this. I call it API runtime, and if I give this a go, so these are the logs from our demo. So if you actually open up, this website, actually I realize that the URL of it is pretty long, but I'll just do it here in the background. So I'll just run this prediction again. A new sort of post request shows up, and it's going to take its time to run the actual prediction and then return back the result. How that makes things clear. I'm sorry, it's going to take a bit. Yeah, there you go. So,
can I ask a question? Sorry. Here. Sorry.
Yes.
So can you explain a bit more how the data set, what kind of data set you use to train this deepfake detection?
For sure.
Yeah.
Well, that's a good question. So actually, it's from this challenge from Kaggle. Let me see if I can pull this up. Kaggle D. This one. This was a couple of years ago, actually, the challenge itself. It was launched 3 years ago and provided about 400 gigabytes of videos, which is here, right? So I'm not sure what the right thing to do here would be, but I would not pull up any videos from this data set because I'm sure there are some policies around actually sharing this data publicly, but this is the source. You can go ahead yourself, enroll into this Kaggle challenge even now, and you get access to this data, right? And yeah, there are many approaches actually to solving this challenge as well, and you can look at how these people have trained this model for themselves and generate the same results on your own computer and whatnot.
And do you know what kind of feature the model is looking at to classify?
Yeah, sure. Let me see if I can pull that up. So this is actually not my code. I'm not an ML scientist. I'm more like an engineer. So I take other people's code and get it to run. But I kind of looked through a little bit of what this person is using to detect deep fakes, right? And I found some really interesting sort of segmentations that these models are doing to get those features out for deepfake detection, right? So some things that are common deepfake will have, they will have deformities around the face, around the eyes, because those are very difficult to imitate for a machine learning model. So you segment those kind of features out from the face after you detect the face itself, right? And then sort of try to see if you can spot patterns in the deformities that common machine learning algorithms will generate while generating a deepfake video, right? And so as you can see here, like there are segmentations around the eyes, especially the harder parts, the nose, right, and that sort of stuff. And a lot of times, the lips won't be in sync, right? That's why they try to hide, or the eyes might not be in sync, so they try to hide the eyes, segment that out, and see if the face is in sync with the video and audio. And similarly, different parts of the face, whether eyes and lips, sort of facial expressions are consistent or not. So that's the thought process behind it. The model itself has some more depth to it, but that's sort of the on top of all of this. Yeah.
Thank you. Thank you. Any other questions from the floor?
Thanks for your presentation.
Thank you.
So when it comes to productionalizing machine learning application, so for sure we could deploy to cloud, but we could also deploy to edge devices, like
right.
the robot that you are currently building.
Right.
So what would be the considerations picking like two paths?
That's a great question. So that's something actually I struggle with on a day-to-day basis, which is understanding when to deploy on the edge and when to deploy on the cloud, right? So firstly, starting with a few challenges of deploying on the edge, right? You have a few edge devices that you can sort of deploy to and are capable of running machine learning models. So a very common one would be these NVIDIA Jetson boards, right? So these are like these tiny little chips that can actually fit on a robot and have some fair amount of GPU compute power, right? But there's a limitation to it, which is that they really heat up during operation, right? Especially if you throw a really complex model at them, anywhere between 80, 85 degrees Celsius on our robots, especially because they're sitting outside under the heat in the ocean, right? And they usually shut off and are not as reliable as you would want them to be, right? So that's one sort of drawback behind edge computing, especially for machine learning, right? But that being said, obviously you reduce latency. So there are some lighter models. For example, I talked about YOLO, right? And that is actually, these Jetson boards are actually fairly sort of capable of running those YOLO models. And YOLO runs, sort of live, a real-time detection model, right? So, for example, our robot uses a sort of real-time variation of YOLO to detect objects in front of it, right? And that's something we can't afford to do on the cloud because we need to give that feedback loop to the robot, right? But then a lot of that tracking and accountability where we have to go into the details of the trash, detect what kind it was, what are the brand stickers on it, and so on and so forth. We use a more complex model. So we also at the same time upload those videos and photos to the cloud and run a heavier model on it, which is a variation of the RCNN models. And that's how we try to divide things up. So, I mean, the drawback with cloud would be that, sometimes you get high latency, you need an internet connection and things like that. But usually for running very heavy models and applications, we just try to offload it to the cloud.
Any more questions for you? If not, then I guess that's pretty much for this session. And thank you, Mr. Raj.
Thank you.
So we got 15 minutes break for now, and then our next section we will start at 3:45. Thanks.
Python 同 architecture 就要過嚟講。代表住 OS Arch 啦，咁就係一個 open source architecture 嘅組織。咁咧就係由一堆建築師啊、工程師啊，同埋啲可能 builder 啊、或者甚至係 maintenance 嘅人咧去組成嘅。咁個目的，呢個組織嘅目的咧，其實主要就係創造一個設計嘅環境，就係全部都係用免費軟件同埋開源軟件啦，咁就可以令到個透明度更加高，同埋一個更加ethic 啊，即係更加有道德嘅一個方向嘅。咁有興趣可以睇一睇個 website 或者 community 都得。好，咁首先關於少少自己啦，咁我大概喺 BIM Industry 就做咗大概6年啦。咁我個 background 咧其實係一個屋宇裝備工程師，咁個產業鏈嘅底層嚟嘅。咁自己都係一個open source 嘅支持者啦。咁平時做嘅都係做 modeling 啊，教下嘢啊，做下啲自動化嘅。咁有興趣起個底嘅可以睇 LinkedIn。好，咁首先啦，今日大家嚟到都見到好多 Python 嘅，其實最主要用喺啲數據資料嘅分析啦、AI 啦，可能做啲網絡嘅相關嘅開發啊、自動化或者一啲軟件嘅prototype 啦。咁但係咧，今次我想講一個好冷門嘅就係 Python 究竟點樣用咗喺呢3方面？係啦。咁首先俾個傳統嘅印象啦，咁究竟大家做建築嘅係點樣樣咧？大家見到喺 CAD 以前，一堆人真係喺間圖房入邊攞支筆圓規去畫圖嘅。咁不論係要 design 定係要學去畫圖咧，都係需要極多嘅時間，非常之多人，咁先至可以做到一個建築啊咁樣出嚟嘅。冇錯，係藝術嚟嘅，佢哋做完出嚟之後，不過需要極多嘅成本，而且極多嘅訓練。咁呢一個咧，純粹係一個sheet list 啦，喺我自己做緊嘢嗰度咧，只不過係 schematic stage 嘅啫。咁10頁入邊一頁幾十張，跟住仲係 schematic 喎，未到 detail 啊，未到tender drawing 嘅喎。咁如果用翻啱啱嗰個方法，你諗下做一單要用幾多年咧？係咪？淨係畫圖咁好啦，啲嘢開始改善啦。咁咧我諗大家都會用啦 AutoCAD。不論你係咪設計師，或者你可能平時畫啲圖嘅，你都可能會接觸到啦。咁一開始佢好耐以前，大概1982年咁開始出。咁喺呢一方面已經係大大咁改善我哋要畫圖嘅嘢㗎啦。咁尤其佢開始咗 Auto Lift 啦。咁喺自動化方面，其實就已經開始咗有呢個苗頭。咁喺最新嗰啲 version， 可能甚至乎有埋一啲簡單嘅 3D model， 你都可以做埋嘅。咁好啦，再繼續發展啦。咁就有啲 3D Max 啦，有 Blender 啦。咁呢一啲都係做 3D 非常之好用嘅軟件，亦都好常用㗎啦喺業界。咁今日咧我想比較聚焦於另一個 Rhino 3D。咁呢一個咧就係我公司啲則師大佬啊，佢哋都經常用嘅。點解咧？第一，佢係專做俾建築師用嚟做設計嘅。佢喺個 freeform 嘅方面咧，即係例如嗰棟大廈點樣扭法啊，扭得好神奇咧 ，Rhino 3D 就係你需要嘅嘢啦。OK， 咁尤其佢喺做 rendering 啦，都非常之唔錯啦。而且你要改，則師成日改噶嘛，咁你要做快速嘅改變咧，都係啱噶啦。咁2007年開始出啦，就係出一個叫做 Grasshopper 嘅嘢。咁咩嚟嘅咧？佢就係一個 visual programming 嘅 add-on。咁佢就係一個 look base 啦。咁佢例如你好多想點講？你個設計好唔同，你個可能改一個 looks， 咁你就可以有一個更加新嘅設計，俾個則師可以睇到去做 study。咁而呢一個 Grasshopper 呢個 add-in 咧係包含咗一個 Python 嘅 looks 嘅，即係你可以喺入邊寫 Python 嘅，就右下角咁樣嘅。咁佢有好多個預設咗個 looks 嘅，只要你入唔同嘅參數，譬如喺呢一度，咁咧佢 generate 出嚟嘅設計咧就會越嚟越多。咁 OK， organic 嘅 design， 點樣扭法，你而家又可以玩得好多啦，係咪？咁但係咧，呢啲 looks 咧，對於一個 condition 啊或者做 looping 咧，其實你要嘥好多時間去用佢嗰啲 default 嘅 looks 嚟做嘅。咁嘅時候咧，你就需要用到 Python。咁例如啦，而家佢呢度咁多圓圈啦，大家見到每一個圓圈佢而家好平均咁樣分咗17份。咁好啦，既然你可以分17份，即師就會問你：喂，我唔想喎，我想第一個就17份，第二個就15份，之後13份，再上翻去就15份。咁嘅時候咧，你就需要用到 Python 嘅 looks 咧嚟去做一個 for loop。你黑曲都冇問題㗎，佢試嘅啫嘛，係咪？咁咧就一直咁樣砌落去，咁佢哋又得到唔同嘅 design 做 study。呢個時候咧，你就需要用 Python 啦。咁講起 Python 呢一個咧，喺 Grasshopper 入邊，佢個 Python 係 Iron Python 嚟嘅，而且係2.7。咁係一個非常之古老嘅一個 version 啦。但係咧佢就支持到 .NET Framework 4，而且你亦都見到啦，佢哋嗰個嗰啲作者咧，其實就係 Microsoft 啦，同埋係.NET Foundation 去創造出嚟嘅。咁你都知道用呢啲咁古老嘅嘢，我諗大家都用 Python 起碼3.6以上㗎啦，係咪？咁就好難嘅。而且 Iron Python 佢冇乜可能會轉做3㗎啦，因為指紋樓梯響就真係見唔到佢會出嚟咯。而且要入翻 Grasshopper 亦都係一件冇乜可能嘅事。咁唔止嘅，當你玩到 Python 嘅時候咧，就有好多人會做一啲更加多嘅工具出嚟去做啦。譬如就係 Ladybug 啦。咁 Ladybug 係咩嚟嘅咧？首先喺個 GitHub 上，佢係 open source 嘅。佢喺GitHub 上邊咧，絕大部分都係用 Python 寫嘅。咁佢就專係用嚟做啲環境嘅環境嘅 study 啊，你可持續發展啊，呢啲嘢究竟點樣？咁佢就可以俾到一個非常之快嘅 reference，俾到啲則師究竟去決定佢嗰個大樓究竟有啲乜嘢嘅要改善嘅地方。咁而且佢亦都需要用 weather data 嚟做，即係譬如城大啊或者香港天文台都有提供嘅。咁好啦，嗱，譬如有少少例子啦。如果有做冷氣嘅朋友，咁啊知道有個 side chart 嘅嘢啦。呢個就係講緊嗰個空氣嗰個 property 啦。跟住你 sun path， 假如譬如一個例子啦，你個 sun path 專係向南邊係特別見到多太陽嘅，咁會唔會可能做少啲窗啊？咁你個就冇咁熱咯，你個室內係咪？咁同埋有 wind mode 可以睇到你究竟啲風喺邊度嚟，幾快？咁咧呢啲咧都係會影響到個則師嘅設計。咁而有呢一啲嘢咧，咁而有呢個 Ladybug 嘅工具咧，就可以幫助到則師究竟佢哋個設計會點樣樣咯。咁唔單止嘅 Ladybug 係有啲兄弟嘅，全部都係用昆蟲嘅，你明唔明㗎啦？咁譬如可能大家如果做軟件多嘅，咁可能Butterfly 啦。就會相關啲啦。點解咧？因為呢一個咧係用嚟做 indoor airflow。咁有啲例子咧就係用類似嘅嘢嚟做 data center 嗰啲 crack 機啊。你究竟點樣擺法？佢就幫你 simulate 一次。咁你 simulate 之後，你可能會諗，你抵出喎，你 crack 機，我可唔可以加幾塊板落去，加強佢個 ventilation，令到佢個嗰啲 server 冇咁熱咧？係咪啊？咁嘅時候，呢一啲咁嘅 simulation 就幫到你啦。好，唔單止咁，以前啱啱講嗰啲咧，都係一啲好 geometry 嘅嘢，即係純粹都係一個模型啊、點線面啊嗰啲咁嘅嘢。BIM model、building information modeling 亦都係政府呢期嘅 buzzword 啦。OK， 只要你做一樣嘢，就派錢俾你㗎。咁咩嚟嘅咧？嗱喺 CIC 佢嗰度有少少定義啦，就係話呢一個係一個流程。咁咧就係用嚟創造啊，或者管理成個大廈嘅嗰啲數據，直接由佢個 design 去到佢最尾就 maintenance handover 做 maintenance 嘅時候幾一樣嘢。咁大家做開 Python 嘅未必明佢講咩嘅。下邊睇呢個，簡單啲嚟講係一個 database， 就將所有呢個大樓嘅數碼數據就擺落個 database 嗰度。而呢啲 data 咧係包含埋你 architectural 嘅設計啦，你工程嘅計算啦，同埋你點樣想起呢棟樓，或者你要注意啲咩嘅 data。咁呢 嗱，Beam 嘅創造嘅軟件咧，其實就唔多嘅，係啦。尤其喺工程界，呢啲軟件係 dominant 嚟嘅，尤其 Autodesk，啱啱 AutoCAD 都係佢哋做嘅。咁就有 Revit 啦，而第二個多人用其實都比例上比較少嘅就係 ArchiCAD，由 Graphic Software 所做嘅。咁今次咧，我會着重多啲講 Revit。咁好啦，咁 Pythoners 咁大家都係寫曲嘅，咁點樣去理解呢樣嘢咧？好，而咁 Beam 咧就注重一樣嘢叫 parametric modeling。如果寫 Python 嘅話咧，你可以諗係 object-oriented 嘅 modeling。咩意思咧？譬如呢一埲牆喺啱啱 While 嘅世界入邊，佢係一埲牆點線面所組成嘅。但係喺 Beam 嘅世界嚟講，佢其實呢一樣嘢係由可能 structure， 跟住再入邊話俾你聽，原來係由呢一個物料咁厚咁樣嚟砌到呢一幅牆出嚟。而呢一幅牆係有個 function 係外牆啦、internal partition 啦、佢個roughness 啊，佢個邊一個做咩 cost， 你都係要搭入去嘅。咁呢一樣嘢咧就有個 parametric 嘅概念。簡單啲嚟講，就好似起一個 class， 一個 wall 嘅 class， 你要 define 好多譬如 structure 啊、roughness、colour 啊呢一啲。咁咧下邊呢個就係一個 wall， 然之後你個 structure 就係 timber、wood、insulation 呢啲其實都係一個 class 嚟嘅。咁嘅時候你就開始明白，原來呢一埲牆就係structure 又咁樣組成 function 係 exterior、roughness 等等等等。你將啲 parameter 入落去，你先至整到 exactly 一幅牆，而唔係就咁點線面。我哋有一個四方形，就唔單止係咁樣樣嘅。咁好啦，喺 Revit 嚟講，佢有一個非常類似 Grasshopper 嘅一個 add-in 叫做 Dynamo。咁呢一個咧，亦都係 look base 啦，亦都係有 Python 嘅 looks。俾你可以用到嘅，不過同 Grasshopper 有啲唔同。Grasshopper 佢注重於個外形，而呢一個注重你個 data 同埋你嘅 information。正如啱啱佢所講 ，Beam 其實你當佢係個 database， 咁你就開始明啦。咁而佢都係用 Iron Python 嘅，而佢喺 WinForm， 即係你亦都可以用 Iron Python 嚟砌一個 WinForm 出嚟做自己嘅啲行為啊，叫 user 去做一啲你想佢做嘅嘢。咁而且咧 C 佢係 support 到 C Python 嘅，咁相比啱啱 Grasshopper 咧，呢個就會好啲咯，跟得上時代多啲咯。不過都好似係 C Python 3.6㗎啫，冇啲新嘅嘢。咁好啦，俾少少 example 出嚟。咁呢個好常見啦，architectural 嘅 example。即使同你講，喂，我想呢度咧嗰個佛沙咧，即係個大廈外牆咧，呢啲 panel 而家咁樣好 dry 喎。我想加多啲唔同顏色喎 ，OK， 咁可以用 Dynamo 做到嘅，就咁同嗰種 Dynamo。咁我可以寫個 Dynamo，跟住出嚟個 result，紅色、藍色、黃色全部係 random 嘅，冇問題。OK， 呢度不過講明啊，呢個係簡單咗嘅 project 啊，真嗰個 project 有起碼2000塊嘅，咁就都知道慳咗幾多時間啦。而且即時可以俾到 quantity 話到俾你聽，幾多塊紅色，幾多塊綠色，冇問題 ，very good， 佢哋都好中意。不過可以，如果你加咗 Python 嘅話，可以再好啲。咩意思咧？呢一度個 Python looks 就一嘢過將呢度鏟晒。點解咧？因為呢一度咧其實係做咗啲好蠢嘅嘢。咩意思啊？譬如我要做 randomness， 我就要由0至4揀一個數字之間揀個數字，然之後再 round up 佢。咁佢就出到0至4嘅好多唔同類型嘅數字，跟住攞呢個數字嚟攞翻我嗰啲 panel 嗰啲 class 究竟係點樣排法，好蠢。喺 Python 嚟講簡單 ，import 個 random module， 然之後行一個 for loop 就攞晒啦。OK， 相比喺普通 look space 嘅話咧，呢啲係非常之有效啦。而都係嗰句啦，即使想玩嘢嘅時候，佢唔單止想講，佢想再多啲。我想要 progressive 嘅。喺下層我個 random 咧就要灰色啊、淺灰色，去到中間咧就要得灰色，跟住去到最上層咧我要深灰同灰色。喺你咁嘅時候咧，就咁用 look base 唔得，真係要用到 Python 啊呢個時候。好，咁再舉啲 example 啦，香港某個 project 啦，咁咧就係喺個外牆嗰度咧就有啲 louver， 現實嗰個 project 起碼有300幾個，而呢個只不過 final design 啫喎。佢喺設計師設計嘅時候咧，你 密啲，你疏啲又有3個，每一個唔同嘅 curve 有3個，加埋900個，即係有2700個 looper 要用手搞唔知幾多星期。不過咧，如果用咗Dynamo 再加埋 Python 咧，咁每一個 looper 計翻佢呢條線嗰個高度，然之後將呢個數值assign翻落去個 looper 呢個 family 呢個 class 嗰度咧，咁咧就可以好快咁樣做到直思想做嘅嘢啦。咁亦都同時之間咧可以俾到一個 quantity 出嚟，可以話到俾 contractor 聽，喂，我咁長，呢一個組件咁長，呢個組件有咁多個，報個價嚟啊！咁佢就唔需要估啦，或者唔需要攞個平均數，你就好快咁樣做咗出嚟。咁講完 architectural 咯，有少少工程嘅 example， 譬如派花灑頭啦，大家都見到呢度起碼一行5個，咁多行50個左右啦，係咪？呢個時候咧就要再用得多啲 Python 嘅嘢啦。點解咧？因為喺 Revit 嗰個API 嚟講咧，佢好多 default look 係冇 MEP 嘅嘢㗎，即係冇呢啲風火水電嘅嘢㗎。佢只係得好多 architectural 嘅嘢。咁嘅時候你就一定要用 Azure Python 去攞佢啲MEP 嘅 API 啦，亦都冇得走嘅呢個。所以咁呢一個 example 咧就係講緊，喂，我呢度咁多個頭，我呢度有咁多條批，我想將呢一頭連去呢條批嗰度。咁我就下一個 Dynamo 啦，下一個 Dynamo 嘅 script 啦。咁咧下完之後，佢就自己去搞掂啦。咁如果50個頭呢一度我要做係咪都要嘥幾個鐘？唔止啦。咁但係而家我只要我用 Python 加 Dynamo 嘅時候，我就可以一次過一個人可能頂5個人，亦都只需要可能1個鐘搞掂。係啦，咁慳咗非常之多嘅時間。再一個例子，呢個比較好嘅，呢個我做緊嘅呢一個，就係假如你望下隔離呢個 binary tree， 再望下左邊嘅呢一個批嘅 layout， 係咪覺得好近？咁嘅時候咧，就可以用到一個叫做 BFS 嘅搜索嘅 algorithm。咩嚟嘅咧？就係話，譬如你由5去到7，你幫我揾佢之間嗰個經過咗啲乜嘢？譬如5啦、2啦、1、4、7，你用呢一個 algorithm 咧，佢就可以揾到究竟呢條路係點樣行，擺翻落去 MEP 消防喉嗰度。咦，我可以由呢一度或者呢一度啦。我揾我究竟有幾多個消防頭，即係你呢度見到有幾多個消防頭。根據翻 BSEN 12845嘅設計嘅手冊，我就可以揾得翻呢一條喉究竟要幾粗。因為其實佢啲係全部都係有規則嘅。你唔可以話OK， 我咁多個頭，我又係60個喉，係唔得嘅。你一定要根據翻佢個表出嚟。咁呢個時候用翻呢一個咁嘅 algorithm， 我就可以揾到，呢度有32個頭，我可能用100mm 嘅喉。咁嘅時候我就可以自動化砌到呢樣嘢出嚟啦。唔單止嘅，如果係用 air duct 喺啲風喉嗰度嘅話咧，其實你就可以佢有一把風喉尺，咁咧你就可以一路行，譬如一開始嘅 pressure 係幾多，一路行扣減到幾多，你就可以揾得翻個 air flow、air pressure 出嚟。Airflow 係真係冷氣嗰個，唔係 data science 嗰個。咁你揾出嚟咧，係咪咁就快好多啦？雖則係我知道好多 contractor 自己有個 Excel 表嘅，咁但係咧，你可以將呢一啲嘢自動咁樣掉落去 Excel 咧，咁你又減少咗人為錯誤咯喎。再唔係嘅，將 Excel 表嗰個計算方法掉翻入嚟，又可以好快得到出究竟 airflow、air pressure 得翻幾多，啱唔啱嚟？係啦。做水口得嘅一樣嘅啫，最緊要都用呢個 algorithm。咁construction 啦，可能有啲structure 嘅 slab 啦，呢一方面我比較少，咁都有2個例子嘅。首先 slab 面，其實咧你一次過要將佢擺晒落嚟咧，你諗下你要逐個擺咧係好嘥時間，亦都好蠢嘅。咁同樣地，又係用一個Dynamo， 再加埋 Python 去將嗰啲散嘅線咧，有可能嘅線就黐埋嘅時候咧，咁佢就可以好快咁樣形成咗一個面出嚟，你就可以利用嗰個面做一個 floor 嘅 class， 係啦，呢樣嘢亦都係佢需要嘅，咁就可以好快咁樣去做到出嚟，然之後 喺個 slab 嘅圖嗰度咧，佢又會有啲 slab 嘅 numbering 啦，你又要擺翻落去啦。喺咁嘅時候，你又慳咗好多時間，又可以早啲收工啦。做工程係成日夜收工，咁啊快啲翻屋企啦可以。咁仲有 foundation 啦 ，foundation 可能你要排工字鐵、排 social power， 咁佢俾條線你又再跟住條線咁樣排法，咁你又係可以快啲啦。而且你嗰個地形你挖嘅時候咧，又可能有高高低低，咁係唔係又可以用同樣嘅方法去令到即係計翻個高度之後擺翻落去 social power， 咁你就可以又好快咁又可以早收工啦。Supervisor 問你：喂，你搞掂未啊？未啊，不過自己瞓覺。咁唔單止，再 extend 多啲，就再加埋 generative design 同埋 machine learning。點玩咧？譬如 generative design 啦，你就係入唔同嘅參數，你有唔同嘅要求，咁咧佢就會一個叫binary 啊 ，Dynamo 入邊有個 binary 咧，就根據你唔同嘅參數咧，就 generate 唔同嘅 result 出嚟俾你。咁呢個時候你就可以個職師就會諗，呢個設計幾好，我就揀呢一個，喺10個入邊揀呢一個。以前你要自己去 design 嘅話咧，又係好嘥時間嘅。而家將呢個 design 快好多。而關於 AI 嘅應用咧，呢度右邊亦都可以見到。咁你 AI train 出嚟，其實你都係有一個規則啦。你個socket 要幾遠啊？你個 socket 你條線 K 唔 cater 到啊？呢一啲咁嘅嘢，你只要一直喺度 train 你個 AI 咧，咁佢就會識得去幫你做咗一個好 preliminary 嘅 design。然之後你 engineer 自己再細執，咁慳咗好多時間。呢個情況之下，咁有興趣嘅可以睇到去啲 source 咁睇。咁好啦，啱啱講完 Beam、Rhino 呢一啲，全部都係 proprietary software 嚟嘅喎，啱唔啱啊？我開唔到我個Revit 檔嘅喎，我一棟大廈起碼用50年，真係邊度出事嗰陣，我到時想開翻個 model 嚟睇，唔掂嘅喎。咁呢個時候咧就有啲 open standard 啦。咩嚟嘅咧？簡單嚟講，佢都係一個 database， 不過咧佢就係一個開放 database。如果以我哋平常人即係做 Python 嘅人嚟講咧，或者做開 Office 嘅work 嘅人嚟講咧，我哋 Office 平時可能 DOC， 而 open source 就係 ODF。同樣地，佢喺 Beam 嚟講 ，close 嘅係 RET，open 嘅係 IFC， 係啦。咁咧係一個都係一個 ISO 嚟嘅 ，ISO standard 嚟嘅，所以用佢咧冇乜點死㗎啦，係啦。咁到時而且佢哋有好多唔同嘅 software 啦，譬如你個 Beam model 你做完啦，你要 share 俾其他嘅 software 嘅時候咧 ，IFC 咧通常都係佢哋嘅選擇，因為其他 software 係開唔到 RET 嘅，或者好難先至開到嘅，好少見。係啦。咁做 Open Beam 嘅有冇啲咩工具啊？OS Arch 就係全力 support 緊呢個叫做 Blender Beam Add-on 嘅嘢。睇個名都知啦 ，Blender 加 Beam， 而且係 Blender 上面嘅 Add-on， 非常之直接。咁佢就係用嚟做一個好靚啦、夠 detail 而且非常之豐富嘅 Open Beam model。咁 Blender Beam 咧就係一個完全免費而且開源嘅 Blender Add-on， 就係俾 architect 啊、engineering 啊去做一個 IFC 嘅 offering。相比以前嚟講咧，你就需要用到可能啲 proprietary 嘅 software 做完出嚟之後 export 做 IFC， 但係而家唔係啦，直接你就做個 IFC 出嚟，唔使搞咁多嘢。而個 primary contributor 咧就啲人啦，咁 website 隨便。咁好啦，解釋一下下邊嗱，你見到 Blender Open Beam 夾埋做一個 Blender Beam 嘅 add-on 啦，但係淨係得佢係唔得嘅，背後咧係有一個叫 IFC Open Shell 嘅嘢。佢咧就係一個C++ 嘅 program 啦，但係咧就係用Python 嚟行嘅。有呢一個 IFC Open Shell 加埋 Blender 嘅強大嘅modeling 嘅功能咧，就可以做到一個 Blender Beam Add-on。咁有少少 example， 譬如而家首先有咩好處 ？Cross platform， 啱啱講嘅 software 基本上100% 冇 Linux 嘅，最多可能有1-2個係有 Mac version 嘅啫。咁我唔想用 Windows， 又或者因為我唔中意 Windows 11係都要開個 account 嘅，咁我可唔可以選擇 Linux 咧？咁有 Linux 做 Beam 嘅 有冇 software 咧？可以話俾你聽冇嘅，係啦，好慘嘅。咁而家咧就主力做緊Pandas Beam 咧，就可以俾到你一個多嘅選擇，全力開發緊。咁呢個 add-on 而家可以做到嘅 read write 啦，唔單止 read 啦，仲可以你改咗嘢，再可以寫翻 IFC 出嚟 ，round tripping 嘅最緊要。咁你啲 parameter 啱啱好似見到 parameter 啊，咁你全部都可以讀翻晒出嚟。咁你就唔需要啲專用嘅軟件，或者要買一個 license 你先要讀得翻。咁呢啲好 basic 嘅 offering 啊，整個圖紙出嚟啊，呢啲咧都已經開始 support 緊㗎啦。咁唔單止嘅，咁仲有 material management 啦，BCF 一個合作嘅格式啦，因為你做編程一定要同其他 contractor consultant 合作㗎啦。同埋可以做個 consultancy scheduling 啊，你有幾多個QS 啊呢啲嘢。咁咧呢期比較少啲嘅就係 MEP 啦，咁但係暫時都可以做到 flow analysis， 同埋一個好重要嘅 clash detection 嘅。係啦，咁但係啱啱都講緊啦，有 Dynamo， 有 Grasshopper、Pandas Beam、Blender 都有。咁再加埋落去嘅就係 IFC look 加 spatial，spatial 其實即係 Grasshopper 烏克蘭文，係啦。再加埋 IFC look 就 Python base 嘅，咁咧基本上都係可以做到啱啱所講嘅例子。咁而且唔單止喎，仲有 VI Suite 呢啲咧就係專注於啱啱譬如 Ladybug 啊嗰啲 environment 嘅 analysis， 咁嘅時候咧就係變咗做一個整體 open source 做 BIM 嘅 environment 啦。好，基本上就係介紹係咁多啦。咁啊，多謝各位收睇，多個嘅想像，感謝大家。係有冇咩問題？
咁多謝阿川嘅分享啦。咁各位有冇啲咩問題想隨便問嘅？
有啲靚仔。
Thank you very much for the wonderful presentation. Please, can you pardon me to ask my question in English?
Yeah, I can understand.
Okay. Thank you very much. Yeah, I actually fall in love with your presentation because I have my background in architecture, but not here in Hong Kong. But I also I've been looking forward to finding a platform for training because of my interest also in programming. So my question is, I want to ask, is there a platform, like a training program for those who have their background in architecture and also they also want to go into programming, just like you have shared? Is there any training program for that whereby one can enroll and learn for a period of time?
Yeah. So you want to know any tutorial for like visual programming, like Dynamo, Grasshopper, things like that?
Yes.
Okay. So first of all, you need to know what you focus on. For example, if you focus on architecture, then of course I'm going to recommend you to learn about Grasshopper. Okay. So for that, actually, the learning source of linking learning is quite recommended because, like, for my own company, we actually use that as a tutorial source. So you need to understand like how Grasshopper works, how Wilo works. Then you need to learn how to use Python to optimize it. Okay, so it is not something that you say, oh, I know Python, then I know how to do it. It's not. You need to do it step by step. Learn Rhino, learn Grasshopper, then learn Python. If you start to feel comfortable or you start to feel, okay, I need to repeat that, I feel stupid, then it is the time for you to learn Python to optimize your existing workflow.
design 度，咁可能你有好多，即係譬如你啲 column 啊、編碼，咁呢啲全部都係repetitive 嘅，咁就可以用 Python 咁幫助到個 design 啦。咁但係如果係一啲existing 嘅 project， 即係譬如可能係做一啲 conservation 嘅，咁有個 existing 嘅 site，咁但係 site 嘅 dimension 其實全部都可能係要再度過，又唔係好容易咁樣可以成個 batch 咁樣 design 晒啲嘢咁。咁 Python on 呢一啲嘅 project 會唔會幫到咧？
嗱，你 existing 嘅 project 咁，我就 assume 你會經由 point cloud， 即係由 3D scanning 跟住 point cloud 掉入去啦。我 assume 呢一個情況其實就比較少 apply 到 Python 嘅，但係我相信都有可能，因為你攞個 point cloud 啦，然之後譬如你一刀斬落個 point cloud 嗰度，你咪會得到一個類似 floor plan 咁嘅嘢嘅。我見過咧，就有人係可以將嗰個 floor plan 咁嘅嘢咧，將佢轉咗去 geometry 先。譬如一啲你會 define 呢一度嗰個即係咁嘅形就係一個 wall 嘅時候咧，咁其實你可以好快速咁樣做到用 Python 嚟做到個 wall 出嚟。呢個我見過嘅，但係你話要應用嘅話，其實我比較少見，係做 existing project 比較少見。但係如果譬如將個舊嘅建築 existing 嘅建築，你想 retrofit 佢咁嘅時候咧，你就可以行翻啱啱嗰個 workflow 啦。係啦，咁嘅時候呢個 Python 就變咗有幫助啦，幫你。
仲有冇其他問題？咁我有其他問題想請教下阿川嘅。咁如果有咗BIM 呢一樣嘢咧，咁 Wino 呢個軟件其實點解即係仲會有人用嘅咧？
嗱，其實咧呢兩樣嘢係相輔相成嘅。咁 Wino 喺early stage 嘅時候咧，其實佢就係用嚟做好多關於好快嘅設計啦。尤其喺個則師好多嘅 idea 嘅時候，有好多 option 嘅時候，咁佢就需要去做好多唔同嘅 study。咁嘅時候 Wino 就有啱用啦。咁點解話相輔相成咧？因為譬如喺 Revit 入邊咧，你係可以去好快速咁樣將 Wino 嘅 model 擺入去。咁你擺入去之後咧，佢一個叫 Wino Inside 嘅嘢咧，佢就可以好快咁樣幫你喺 Wino 嘅 object 咧，就轉咗做一啲 Revit 讀得到嘅 object， 譬如牆身啊、窗啊呢一啲喺 Wino 好常見嘅嘢，其實就會即係好快咁樣做到咯。而且你掉入去嗰陣，你係有 information 嘅，即係你唔會話盲中中，譬如一個 geometry 咁你就算數啦。喺 Wino OK 嘅 ，3D Max OK 嘅 ，Blender OK 嘅，但係 Revit 入邊咧，你可能會話呢一個Wino 入嚟嘅窗係邊一個做啊？幾淺一尺啊？咁呢一啲咁嘅 information 咧，就可以由好快咁樣由 Wino 掉入嚟，經 Wino Inside 咁就可以好快咁樣做到一個 integration 咯。所以就唔可以取代大家嘅，冇得取代嘅。咁但係需要大家，我會話係啦。
Thank you。咁有冇啲唔使經過個 visual programming 就用到 Python 嘅一啲方法咧？
我所知嘅 Wino 咧，其實就暫時係未見到有啲咁嘅嘢嘅。每次你要用 Python，你就一定要開 Grasshopper。咁唔驚啦 ，Grasshopper come with Wino 嘅，咁你咪照用咯。咁但係有啲人係譬如喺 Revit 嚟講，有啲人係唔中意開visual programming 嘅。咁咧佢就可以用啲 add-in 叫做 PyRevit 啦。咁嘅時候你就可以直接用佢個 IDE 嚟執行你想做嘅嘢。你唔使開visual programming， 唔使開 Dynamo， 咁你就直接做咯。我知道佢係會快咗啲嘅，有啲同一個會嘅會員都話佢係唔中意用 visual programming， 淨係用 Python 即刻 run 最爽快，佢覺得係咁樣。咁都有嘅，有咁 option 咯，睇你自己個 prefer 咯，睇自己 prefer 啲乜咯，係咯。
好 ，thank you。仲有
另外有一個問題想問，你提到頭先即係你個 talk 講到 Revit 啦、Dynamo 同埋 IFC 啦，即係譬如同埋 Blender 咁樣啦，即係同埋 OpenBeam 咁。咁譬如 Revit 同埋 Dynamo 都係好，我諗喺業界好 common 嘅，一直都因為好 common 用。咁但係譬如 IFC 啊或者 OpenBeam 或者 Blender 喺而家香港業界據你所知係咪即係慢慢都會 adopt 咧？因為應該都係譬如 IFC 都有咗好耐啦，但係都唔係好多人 adopt 據我所知。咁而家嘅情況係點樣咧？
嗱，首先 IFC 譬如喺以前啦，就係 2.3 啦，2X3 啦。喺嗰個時候咧，其實個 supporting 譬如唔同嘅tray 啊，唔同嘅 discipline 嘅 supporting 咧係冇咁好嘅。認真嗰陣亦都係heavy develop 緊。咁但係由 IFC 4啦開始啦， 同埋而家嘅 IFC 4.3啦，再加埋啲師傅嘅一啲discipline 啦，咁嘅時候咧，其實喺點講啊？佢個包容度大咗咯，而且佢嗰啲 definition 咧係清晰咗嘅，比起以前 2X3。你話喺香港 adoption， OpenBeam 香港其實每年都有個獎項㗎啦。咁咧佢哋 show 出嚟得獎嘅作品咧，通常都係點樣喺唔同嘅軟件之間用到 IFC 嚟俾唔同嘅軟件做interoperability。喺呢一個情況之下，應用係最多係咁嘅情況。咁但係OS Arch 即係個組織覺得，喂，你每次嘅轉換其實你會 lost 咗 data， 而 data 就係 BEAM 嘅一個最核心嘅嘢。你 lost 咗 data， 即係你嗰個 project 有不足啦。咁所以我哋就點解會想用 BenderBeam 嚟做一個 native 嘅 IFC offering？ 喺嗰個時候就令到所有嘅軟件都可能係做到最大嘅 compatibility 咯，係咯。咁應用有嘅，但係通常都係轉換嗰陣。有啲大學我知道佢都有用 IFC OpenShell 嚟做少少研究，係啦，即係做啲 spacing 嘅研究我都知嘅，係啦。越嚟越多我會話多過以前嘅，明顯地。
咁譬如如果係一個新學嘅人，係咪應該學咗 Blender 嘅 OpenBeam 嘅 plugin 先？唔好，我會建議你係學嘅，你學咗 Revit 先。冇錯，佢係 proprietary， 但唔好當佢係一個邪惡嘅嘢。OK， 最緊要唔好當佢邪惡嘅嘢。學咗 proprietary， 知道佢嗰個 workflow 係點樣行。因為 Revit 最大嘅好處就係成個業界都接納啊。我而家做個 project，同沙地阿拉伯再同埋英國 studio 一齊教嘅時候咧，其實大家都係用緊 Revit， 用緊 Autodesk 嘅嗰個 eco environment， 由佢個Revit 到BEAM 360啦，其實佢哋最高嘅 compatibility 㗎啦。咁其實最好嘅就係學咗佢先，開始明白到嗰套 BEAM 嘅 workflow， 你開始明白到佢係一個 database 嘅時候咧，你就可以開始睇 IFC schema。明白到 IFC schema， 再可能係試下 contribute BenderBeam 啊！啲人都好好㗎，我俾啲爛曲佢幫我執靚仔佢，咁我又學到嘢，係咪？咁啊，大家都好，而且又係 open source， 咁啊開心啦，個個都開心啦，個個得益 ，open source 嘅好處。 Thank you， 有冇其他問題咧？
handling 或者 detection on 本身我嗰個 3D model， 即係譬如可能我用 Rhino 嘅，咁跟住然之後可能我啲 service 係冇 close 到，我嚿嘢冇 block 到咁樣，跟住然之後我就將呢啲嘢掟咗落去 Python， 即係佢可唔可以check 到啊？我條線其實我係冇 close 到嘅喎，或者點樣再去可能 gen 翻個 report 俾我聽，話俾我聽邊度有呢啲問題。
即係譬如可能你個 model 假設啦，你條水喉佢冇掂到一個 fitting。係咪咁嘅意思？
係啦，類似咁樣。
嗱可以嘅，咁但係都唔一定要用 Python， 你可以用 Python。我亦 actually 你需要用到 Python， 因為你要攞到嗰條批嘅連接電。喺譬如我啱啱呢一個 BFS 嗰度啦，其實我就係攞每一個呢條批究竟連接咗邊一度，連接咗一個 fitting。而呢一度係冇，咁我連接咗嗰條 list 係即係得一個啦，即係得個0啦。咁嘅時候，我咪知道佢冇 connect 到咯。係咪？假如譬如呢一條批，佢係有2個節點嘅連接咗，咁即係話佢係 perfect fully connected。咁我咪知道究竟邊一條冇 connect 到咯？因為有好多人咧做啲 model 咧搞碰嘅啫嘛，係咯，搞碰咁擺過去咯。咁但係我真係要 check 你嘅時候。咁我就梗係咁樣去炒你啦，係咪？係啦，係得嘅，係啦，係得嘅。
咁我哋好多謝阿川嘅分享啦，咁大家再俾多一次嘅掌聲俾佢啦。Thank you。
好 ，thank you。
多謝晒。咁就下一位嘅 speaker 就可以準備㗎啦。
Microsoft, and a content creator in YouTube who had more than 100,000 subscribers, 100,000 views. He had mentored students in Google Coding 2019 for the TensorFlow organization, and have judged multiple hackathons across engineering colleges in India. So shall we welcome Mr. Vijay.
Hi everyone. First of all, thank you for taking out time and attending the session. I hope I'm clearly audible to everyone. Okay, great. Thanks for the wonderful introduction, Yuan. So yeah, as you mentioned, I work for Microsoft. I specifically work in the Office Android platform team where we build the Word, Excel, PowerPoint applications. And I am also a content creator, more towards the technical content I create on YouTube, and I create content over LinkedIn as well. Today, I'll be sharing my experience. So I have worked with a startup as well, which is a Munich-based startup called Stack Guardian. It is an IAC-based platform, which means infrastructure as code platform, where we automated the deployment of infrastructure over different cloud platforms. And the whole platform was built with Django. Django is a macro framework built with Python. And so we did all the researches, and along the way, we found out, we accumulated a lot of information. We made a lot of mistakes. We did a lot of experiments, and on the way, we figured out what actually works well with Django, and how someone can write microservices, which is very buzz these days in Django framework. So I'll be talking about that only today. So these are topics in the store for all of you. We'll be walking through monolith first of all, and how to move away from monoliths. Then we'll be talking about microservices, why and what are those. Then we'll be specifically talking about Django microservices, how to actually build Django microservices, and then the actual crunch of this particular session, which is the mistakes to avoid while building Django microservices, and then a fun trivia by the end of the session. Moving ahead. So you might have seen this image. There are monoliths appearing in Utah, in US, and there are so many other places. But we'll be talking about the monolith architecture. So what does that mean? So a lot of people have this misconception that monoliths are just huge systems, and everything is combined into one single machine, and the clients are directly interacting with a single machine. And for microservices are tiny systems or machines, and clients send requests to each of those machines, which is a misconception actually. Monoliths we can also scale out monoliths. They can be horizontally scaled out. It's not like there is only one machine when it comes to monoliths. It's just we can replicate it out, and we can horizontally scale it. So if I go through the general since each and every part of a monolith touches each other, if there is a change, and the changes are interdependent, so deployments gets very difficult because since changes are interdependent, there needs to be a proper cycle of deployment. Because changes are interdependent, one change cannot go before the other, then there will be conflicts, and then the system may crash in future. Deployments are very, very complicated. Any small change require monitoring as well, and monitoring as well as all the teams need to be coordinating with each other in order to make the deployment successful. Then comes testing. Now, as I mentioned, all the components in a monolith touches each other or tightly coupled. There needs to be proper testing required. The test cases need to be, so writing test cases becomes more complex because you need to take care about each and every bit, either dependent, tightly coupled, or loosely coupled. You need to take care of each of the element of that monolith. So that's why the testing becomes very difficult. Now comes the single point of failure. Now what does that mean? So as I mentioned, although we can scale out horizontally a monolith, you can create replicas of it, but you can increase the number of servers in order to increase the compute. But even if there is a bug in any of the servers, since the servers are identical, the computation is identical, even if there is a problem in one of the server, it will lead to a crash of the whole system. And that's why we have a single point of failure in monoliths, and this is one of the major disadvantages with monolith. And then comes the adaptability, which means that since the complete system or the complete application, with time it gets too large and complex, with the upcoming technologies, it's very difficult to move to new technology because every now and then we get to know about different frameworks, different libraries, and in order to ramp up or align with the new technology, if the system is too large, the costing to move from the previous technology to the new technology gets very difficult, and that's why this is one of the major disadvantages with the monolith architecture. Okay. In case, if anyone has any questions in between, please either raise your hand or we can take all the questions by the end of the session. Now, there are a lot of big companies who have actually ditched monolith architecture. And if I name a few, they are Amazon. So if you go to Amazon today, their payment system is a completely different microservice. Their profile is a completely different microservice. And their product listing page, each and every bit is a different microservice. Netflix have their payment system, have their streaming system. They both are they are loosely coupled and different services running on different servers. Uber is one of the examples, and eBay is also one of the examples. But what are microservices, and why we actually moving towards microservices? That's the main question. So if I talk about, with a general example, when users or, for example, mobile phones interact with different services in order to get responses as per their requirement. For example, if I'm a user, I'm going to Amazon and I'm looking to my profile. I just need the profile service, a response from the profile service. I don't care about the payment service at this time. And this is where this is what actually the microservice architecture, where different services are loosely coupled, and you actually get the responses based on your requirement. So if I talk about, okay, yeah, that's actually, for example, one is the auth service can be one microservice. The payment system can be one microservice, and this is how the microservice architecture is defined. So it's a approach to build components which are loosely coupled, and each of the components are has specific goals with respect to the business, and they are not directly dependent. They are not tightly dependent on each other. Yeah, so that is the general introduction of microservices. But why we actually need microservices? Now, if a platform or a particular a system has separated out the responsibility, they are not directly dependent, and they can work independently and deploy on the go whenever they are ready. Okay. Then improved fault isolation. What does that mean? Now, when it comes to monolith, you don't know. For example, if a system crashes, you generally don't know which actually is the culprit or what is actually consuming the lot of compute. For example, if your system is suddenly started consuming a lot of load, or suddenly started consuming a lot of compute, now it's very difficult in monolith to identify who is the culprit. But in microservices, since there is a separation of resources, there is a separation of services, it's very easy to identify which particular service is actually causing the issue. And that's why companies are moving towards, and these advantages are very convincing, and that's why companies are actually moving towards the microservices architecture. I'll wait for. Okay. But everything has its own challenges. It's not like that microservices is kind of perfect. Nothing is perfect. Perfection is a myth, actually. So even microservices has its own challenges. For example, if a company, so initially designing a monolith is very easy and convincing for any particular platform, and every other company should move to a microservices, not because they want to scale out, but they should start thinking about moving to a microservice architecture when their teams actually scale out. When your team started to grow, your members want to work on different products and want to have ownership of those products, then only you should consider, then only a company or a small team should consider moving to the microservice architecture. Because designing a microservice architecture is very difficult, because it requires, you need to define the boundaries of separation. Which particular service needs to be decoupled? What should be the you need to define the areas of responsibilities. For example, there is one of the very bad practices being followed while defining microservices is, if a service is only interacting with another service, then you should actually not decouple them, but consider it as a single service. Because if service 1 is only interacting with service 2, you should never divide those services into 2 different microservices, but combine them into a single service, because S1 is only interacting with S2. And since there is a single dependency, one should never, it actually increases the cost, and it's not going to help anyways. So this is one of the major mistakes or major bad practices that companies generally do while moving towards microservices. Okay, yeah, that's done. Inter-service communication. Now, so every particular service needs to get or receive data from other services. In monoliths, what we have is everything is in a single scope, so we just do a function call. And that's how we get the responses out of them, and that's very quick. But when it comes to microservices, we need to do a network call, or maybe a gRPC call, which means a Google remote procedure call. And this requires network bandwidth and requires a lot more time than a function call. And that's where, these are some of the challenges with microservices. Now, in a microservice, each and every microservice should have its own dedicated database. Because if we have a single database, that will cause a lot of conflicts, because each microservice has its own schema, and it will create a lot of load on the single database. Hence, it is one of the good practices to have a dedicated database for each and every microservice, and this leads to a lot of costing as well, because the more the microservices we'll have, the more the databases we'll have, the more computation we'll require, and then the more costing we'll have to incur. Okay, moving on to the next part, which is Django microservices. Now, this is the thing that we actually experimented a lot while working at Stack Guardian, which I already told about, is a IAC platform built completely in Django. We initially started with the monolith architecture. We built everything inside of one single application, and then we divided into different components. One of our components was the marketplace, the other was the authentication service, and then the orchestration service, so on and so forth. So how we actually made that move? So initially, we started with 4 members in the team, and each of the person is actually working on the whole application. It's not like that. We had different roles. Each one of the member know the whole system or the whole code base. But as we evolved and the code base evolved, we added a lot of enhancements. Our team started to scale up, and that's where we decided we should go for the microservice architecture. And that will help us to give ownership to each and every individual in our team. Okay. Yep. The second is define boundaries for each service. Now, when you have a monolith architecture, it's, as I already mentioned, it's very difficult to decouple those services, and that's the most critical part and the most interesting as well. You need to define the boundaries and where to actually define those boundaries. The boundaries needs to be defined where the services are very loosely coupled. I mean, the dependencies are minimum, and so that they can be decoupled, and whenever there's an issue in one service, it should not affect the complete system. Separating resources, that is, adding a dedicated database to each and every service, so that giving a dedicated resource, a dedicated compute server to each and every service, in order to, for example, if a particular service requires a lot of, so the thing with microservices is, for example, if a particular service needs to scale out, you can scale that particular service instead of scaling each and every microservice that you have. And that's allow us to separate resources. For example, if auth service require maybe 2 databases or maybe 3 servers, so based on the requirements, we can separate out the resources. Then inter-process communication, as I've already mentioned. So there are multiple ways to communicate between 2 services. One is the HTTP call, and the other is the gRPC call. But what we figured out is instead of gRPC call, we use HTTP calls, which is more of a convention used in the microservice architecture, and we used it for our use case as well. So this is actually the small, the thing that we do at Stag Guardian, where we take the inputs from our customers in the form of minimal documentation, minimum YAML files, and then we use that particular configuration to deploy their infrastructure over different cloud platforms. Now comes what mistakes one needs to avoid if they are working with Django and they are thinking to move towards the microservice architecture. Apps and the unfaithful migration. So what happens is, so before going to the major mistakes, one small point while regarding creating apps in Django. So what happens is Django tracks model migrations separately for each and every app. And for example, if someone has foreign key linking across different applications, Django migration system will try to create dependency graphs. And sometimes, creating those dependency graphs has a lot, it's not perfect every time, and it has errors in it. And that, unfortunately, this calculation isn't perfect, and this leads to a lot of errors while doing the migrations. And it gets, it will affect a lot when there are a lot of, the number of apps are more. So in order, with respect to the apps, if your particular team is, if you don't want to get confused with apps, you should stick with one single application. If you still want to move to multiple applications, so there are 2 reasons why you want to move to multiple application system. Either you want to scale your particular project to a microservice architecture in future, and that's where you need to consider one thing. Either in the initial front only, you should define the responsibilities explicitly so that it will help you in future whenever you want to move to multiple application system in Django. Squash migrations. Now, what does that mean? So with each and every deployment, Django creates a different migration files. And while deploying the migration, the migration, whatever files are created for migrations, each and every file is ran again in the same order. And if you have multiple databases, it will do it for each and every database. Now, here comes the problem where, for example, one second. Yep. So as the system evolves, it accumulates more and more migrations, and they will take a longer and longer time to run. For example, if you have multiple applications, multiple databases, it will run through all the migrations. It will run through all the migrations, and that will require a lot of time for each and every deployment. With the interest of time, I'll try to finish it quickly. So as I mentioned, yeah, it will require a lot of, the deployment cycle will take a lot of time. If we have multiple databases, and if we'll do, so migration is required with each and every deployment, and if we'll have a lot of migrations, then the deployment cycle will take a lot of time. So what we did there was, so there are two ways in order to avoid this mistake, avoid this deployment delay. One is either to manually clean all the migrations and then do the migration thing again, or use a built-in feature of Django for squashing. So this practice will help you to actually reduce the deployment time if you have a lot of migrations. Less bulky signals. So signal is one of the amazing features that Django provide, where you can control, you can do a few things based on whatever has happened, based on the pre or the post signals. So for example, if model A is being created, you want to do something with model B. Or for example, if an object is created, you want to do some logic at the back end. So the problem with one good practice that we figured out was, it's very difficult to, or I would say impossible to pass arguments in signals. And second thing is, one should never write a lot of business logic in signals. Because in case if anything fails, it will make things more complex, and the system is prone to problems. Okay, then comes the ORM thing. Okay, so for example, if your system has multiple calls to create and delete objects across the board, you need to, and so there is no clean way to create and delete objects in Django when it comes to a lot of, so you might have different, so in a huge system, generally people create and delete objects at a lot of places in the code base. And there is no clean way in Django to create or delete objects through a single entry point. So it's generally advised to create a wrapper over the ORM that Django provides, which means object relational mapping. So what happens is, when you create a wrapper over it, you'll have a single entry point for all the CRUD operations, and that's where, if anything, you can add changes before and after the database events, whatever logic you want to do before the database events at a single place. So it will actually help the engineers to make the deployment convenient and very efficient. Okay. In conclusion, I just want to say that, well, both the approaches have their own pros and cons, and it depends upon the scenario and the product and the project requirements in each, what you have and which trade-off you want to choose. So as monolithic approach best suits with the lightweight or the small teams or small application, it is recommended to adopt monolith approach first, and depending upon the requirement or depending upon the scale of your team, you should move ahead and move to the microservice architecture. A small trivia for you folks is, if you folks have used Django, or if you're using Django, what is the latest version that Django has introduced? Okay. Okay, who has Googled right now? Okay, so when did Django actually made the project open source? Okay, the answer is 2005. It was built in 2003, but it was made open source in 2005. In which year first version of Django released? Even I don't know the answer because I didn't add it here. But what is the approximate cost, you think, of the Django project today? It's an open source project, but it still has a valuation. You can make a guess. 50 million. That's 7 times of the actual price. It's $7 million, US dollars. Okay. If you folks have any questions, please ask directly. And thank you for listening, folks. Really appreciate that. And you can, connect with me on LinkedIn or on Twitter, or you can search my name on YouTube or maybe Google as well. You'll find me.
So are there any questions from the floor?
Hello, thank you for your talk. I have a question about, do you have any tips about learning microservices or using Django? Do you have any tips about learning microservices? If you like,
you mean resources?
Or tips or resources?
I actually have gone through a lot of resources. Maybe I can share those maybe via the coordinators. Maybe I can share those, yeah. And the good part, actually, we have learned it through experiments. It's not like whatever written in books or whatever you see on YouTube or whatever people are teaching, they're more relevant to software engineering or cracking interviews at big MNCs. When it comes to the real world, things get more difficult when you build those. So we actually learn those on the go, and it's not a 1 month or 2 month process. It sometimes takes years. So I worked at Stack Guardian for a year, and we started with a monolith, and along the way we figured out that microservices is something we should move to.
Next question, gentleman over the left side.
Hi. Early on in your talk, you mentioned about microservices having dedicated databases for each one of them. Can you elaborate a little bit on what those, what are the advantages of having dedicated databases? And not just that, a little confused because used to having a single source of truth for data. Right.
Exactly. So you correctly mentioned a single source of truth is required. So if you'll have, so each and every service should have a single source of truth. For example, you have a profile service, you have auth service. The auth service should not depend on the profile service, profile database for any kind of information. Maybe it could be a primary key or something, but not the complete data. So whatever, if some external service requires any information, it should get the complete data from the profile service database only. It should not depend, by any way on the auth service. So that's why dedicated databases are required, and it's more preferred. Eventually, you need to create different schemas if you make use of a single database. So it will eventually, you need to scale it vertically, that particular database, if you consider one only. Yeah.
Yeah, so one question from my side. Can you share a bit more about the serverless architecture?
Yeah. So serverless is actually one of the recent architecture which is being introduced. So what happens in serverless, you don't have to actually care about anything, and you just give all the maintenance about the hardware, about all the management work to a third-party service. For example, my microservices is running 5 functions. A single microservice is running 5 functions. What I can do is I can transfer that responsibility to AWS Lambda, 5 AWS Lambda, and that's what serverless computation is. Serverless architecture is where you delegate the responsibility of a particular microservice functions to different third-party servers. For example, AWS Lambda or Azure functions.
Are there any more questions from the floor? Yes?
Hey, hello. How would you compare using Python with other framework in either in Python or in other language when building a large-scale project?
Okay, that's a very good question actually. So while doing our researches, Django is a macro framework which is also known as a battery-fitted framework. And there are a lot of organizations which prefer Django. So there are a lot of actually platforms like, I guess Spotify is also built with Python only. There are other platforms as well which are built in Django. So the reason we chose Django was, one was community. The community was huge. The second was, it is a battery-fitted framework. It provides a lot of functionalities built in. So that was one of the reasons we actually took this path. There are other reasons also. Building microservices should be feasible. There was a lot of research went into that. But one of the major reasons was the community, and it was open source. Third is the one I mentioned, that it is a battery-fitted framework, which provides a lot of functionalities, and it's very easy to scale. It's a macro framework.
So regarding microservices, do you think there should be a max limit on the number of microservices you should have in a project?
Yeah.
And also, any tips from your experience, any tips on how to manage it, like the release lifecycle, code management, when there are many number of microservices?
Yeah, very good question actually. So when people talk about microservices, they generally think a complete platform should be divided into 10 or 20 or 30 microservices. It's not like that. Generally, a system should only have 2 to 3 microservices. So the only factor one should consider, the major factor is the separation of responsibilities. They should be loosely coupled. It's not like, the dependency should not be tightly coupled. And that's the major consideration one should keep in mind while, so that's what I mentioned in the talk as well. Designing a microservice is actually very tricky, and it's the most difficult part, and requires a lot of costing and documentation as well. What was your second part of the question? So generally, as I mentioned, when the team scales, companies should move to microservice architecture. There, it's kind of a good practice if you're a small startup. Each particular microservice should have an ownership, or 2 persons should be working on it. And depending upon whatever feature enhancements they're doing, they can, so there is no kind of release cycle thing in it, because they can work parallelly, and that's one of the advantages of microservice. They can work parallelly. They can, for example, if auth service has any changes, they can go ahead with the deployment, and the people who, so one of the ways deployment works is blue-green deployment, if you have heard about it. So if the current service, for example, so it happens in stages. We serve the 50% audience. We started, sending the request of 50% audience to the previous version, and then the remaining 50% to the newer version, and subsequently we moved the older audience to the new audience, and this is how the deployment actually works. And yeah. If you still have any doubts, we can maybe talk.
If there are no more questions, shall we give Mr. Vijay a round of applause?
Thank you, everyone.
Thank you very much. And in this case, we would invite Mr. Sammy Fong, our chairman of the organizing committee, to give a closing speech.
Okay, thanks for everyone to staying in PyCon for whole day. It's great to meet with all of you today, and we enjoy the in-person conference that we missed for more than 2 years during the pandemic. We are always proud of having many overseas visitors to join PyCon in Hong Kong. In previous years, with 0+3 restriction, it's very difficult for us to have overseas speaker and participants. Luckily, we still have 2 overseas speakers this year. And we used to have more than 10 before pandemic, and we used to have some overseas participants. In this year, we got at least visiting from Taiwan. Thanks for our overseas speaker and visitors who joined us today in Hong Kong, and they spent extra days in Hong Kong before the conference. We host more overseas Python contributors and users will visit Hong Kong again for PyCon in near future. When we got only 30 tickets sold in the sales period of our early bird tickets, less than half of our users. We are worried about the attendance numbers of PyCon Hong Kong this year, but as of today, we got more than 200 reservations, which is close to our average numbers. Thanks for you guys to coming and also our volunteer teams. Yeah. And with support from the some companies help us make this conference happen again. Thanks for our gold sponsor AWS, and also our gold sponsor Microsoft. So to let us understand more about your experience in PyCon this year, and what are you looking for in the future Python event, please fill the conference survey by Wednesday. We will also post this link on our Facebook page and HKPUG Facebook and Meetup group as well soon this week. We will also have an online chat with 4 international speakers who cannot visit Hong Kong this year. So we'll have an online chat next Saturday. We partner with ConsCom, which is the largest open source conference in Taiwan. And it will also include a wide variety of interest regions particularly applicable. Some example of this topic including NLP refer model backend, real-time messaging with gRPC and Python, deep learning with PyTorch, building data pipeline with Python. If you can help to be one of us session hosts, please contact with us on Facebook or email us. So PyCon Hong Kong is one of worldwide PyCon which are recognized by the Python Software Foundations. I hope you can consider applying for Python Software Foundation voting membership, including the supporting members, which is about $99 US per year. Or if you contribute to Python community, you may also consider to be a contributing member as well. It can help us to continue the development of the Python community. So to sustain the local Python user group and tech community, we are looking for more volunteers to help us organize Python meetups or events. If you're interested to speak at a meetup or organize a meetup or provide a free meeting rooms for us, please feel free to reach out Hong Kong Python user group on Facebook or meetup.com. So what can we organize for the meetups? Just like we can have some talk sharing, we can also organize a development speed on some to head on some Python project. And also we can organize some education program for students and also some other kind of activities. Last but not least, we will have a happy hour to grab some beers at the after the end of conference today. So we can gather at the outside the reception counter to, Kevin Jones will take us to the nearby bar and restaurant. So we hope to meet you again soon in PyCon Hong Kong next year and other other Python meetup as well. So we hope to see you soon. Thank you. Yeah, so this is the end of the conference today. So if you would like to go to the happy hour, let's wait outside. Yeah, thank you.